Uh-oh, I forgot to update the stream title, didn't I? Let's try that. Update the stream title. Think we're live. Oops. All right. Welcome. I did a little bit of work on this over the weekend. Just a little. Nothing too fancy. Let me tweet this out and give Will a little bit of shit. 1 second. Hold on. Let's see if he... Oh, I forgot this. There we go. This is so funny. Okay, let's get started on the MOBA dev. Let's get started on the MOBA dev. I gotta have a little bit of fun, right? Okay. So let me talk about what I did over the weekend here with this. Stash, git pull, origin, any config. There have been a few changes, you could say, but most of them not to the MOBA. I did like a lot of changes to everything else, a lot of refactors and stuff, okay? The main thing with the MOBA is I figured out a new way of doing targeting. Where is it? Right. Pufferlib. Ocean. It's still so funny. I got Will freaking streaming every day now. Will's cool. Will does, he's done a lot of work. Oh, there you are. There you are. You came back. You came over to get back at me. This is no cursor, man. This is like 2 plugins NeoVim. One of them is Super Maven, but it's for completing one line at a time because Python doesn't have good LSPs. That's it. So I figured out over the weekend a way better way of doing targeting. I was trying to figure out how to implement a linked list in Cython without malloc, which was god awful. And then I just figured out a better way of doing it. So, scan. Where is it? Scan AoE. Okay, so this thing returns a bint, which is whether it's scanned anything or not. And this does a loop over the nearby area. And it has a whole bunch of flags for how you want to filter the data. Okay, so you have this singular scan function. And then when you want to actually do something over the scanned things, it is way, 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 way easier because you can do like AUE scanned, for instance, and you can just go over 200 is hard-coded for now. It's just the max number of scan things. And it'll just go over targets until it finds a null terminator. And it will grab the scan target, decide whether to hit it, and move on. So you get rid of this nested loop over nearby area being repeated all over the code base. Now it's just scan-based. So this is very nice. We're going to do something really cool today, which I think will work. At least I haven't come up with a reason that it shouldn't work. And what that is we're going to implement A-star pathing, but we're going to cache it for everything. So what we're going to do, the map is 128 by 128. So that squared is like, I don't know, 150, was it? No, 15,000? Yeah, which is not that big. So essentially, you're going to end up with a 128 by, no, what is it? Is it 10,000 by 10? Hold on. I might be wrong here. Let me figure this out. So it's 128 times 128. Oh, yeah. Times 128 times 128. Okay, this is somewhat bigger than I expected. I don't think that's too bad, though, is it? 268 MB. We could map it as well. So let me say what I was going to do here. I want to pre-compute the pathing from every single tile to every single other tile. So you pick, where you are currently. You pick where you want to go. Hey, JBL. This is actually, I think, the thing that you recommended, right? Is to pre-compute the A-star pathing. So the good news is that we can do it. But I think it's 268 megabytes of data, which maybe is not that bad. I don't know if we can get that into Cython easily. We'll see. But so if we pre-compute from every single position in the map to every single other position in the map, right? That is, I mean, it's 128 by 128 by 128 by 128, right? It's like your XY by their XY, like the target XY. And technically we can prune some stuff out, but I think it would make the data format worse. So I mean, this shouldn't be that bad though, right? Because wait, if we want to do all paths, right? If we want to do all paths, so from any part in the map to any other part of the map, then we don't need A-star, right? We just need breadth first search. Is there anything else clever that we can do here? Is there any other clever way that we can save on this? Because, like, So naively, right, what I can do is I can run breadth first search 128 times 128. So I can run breadth first search 16,000 times on this map. As long as I implement this in Cython, it will be relatively fast. And then I can save that data to a file. And then I will have pre-computed optimal pathing for the whole map. It will be 268 megabytes, assuming I use 1 byte to represent like the path direction that you're going to take in any one location. Technically, I could cut this down by a factor of 4 because I only need 2 bits per direction. So technically, if I want to be really sweaty with this, right? I can do this in 67 MB because I can have each byte could contain, you only need 0, 1, 2, 3 to tell you like up, down, left, right, which is 2 bits. But before we consider that level of optimization, because that's kind of obnoxious, we got to do bit reads. There might be a better way of doing this. I'm just trying to think, is there like, if I go from point A to point B, right? And I go to like some point in the middle along the way, then I already know the optimal point from that one to the end, right? Is there some algorithm I don't know about? I'm going to chat GPT this just to see if I'm being stupid. This is really nice. Just, I only ever use this for, like, I'm not going to expect this to solve the problem for me because it's not. It's just if there is an existing algorithm that I don't know about that will do this. So I need to compute optimal pathing on a 2D grid with obstacles from every point to every other point. Is there... I can run BFS from every start and get this, but that is O n to the 4 memory for the result. There a better algorithm. Floyd Warshall. Ooh. A-star doesn't help. A-star is a faster algorithm for getting from one point to another point. We need all points. So this is exactly the type of thing I was looking for from ChatGPT. They say that they have O of n cubed time and O of n squared memory, where n is the number of... Oh, I think that they're stupid. They redefined n. Hold on. I think that this is stupid. Whoa, wait. If this is ChatGPT being wrong, though, then this is exactly the type of thing I'm talking about. Hold on. Let me confirm that I'm right here. Distance matrix. IJ. Distances. Okay, dynamic programming thing. So... this is literally worse, isn't it? Wait, what the hell? This is worse, right? Yeah, ChatGPT is very highly regarded. It works both ways. In this context would indeed... Hold on, let me see if this algorithm looks like it's good, though. Distance, IJ, is min of distance. IJ plus... Wait, what? I think this is the same as breadth first search. Wait, IJ... No, IK. How is this n cubed time? Oh, shoot, that's a lot. How the hell is this ever better than breadth first search? Wait, Floyd Warshall? This is frickin' ChatGPT wasting my time, as every time. Frickin' everyone on the internet saying it's gonna solve everything, but it can't solve anything. All pair shortest path problem for weighted graphs. Well, this is the actual thing. Oh, perfect. This is what I wanted here. All equals pair. Yeah, that's what I need. I need all pairs. I have the all pair shortest path problem. Exactly. Unweighted graphs, undirected graphs. They don't have memory complexity. Does anybody smart here know if there's actually anything that's better for this problem? So look, this is the problem that I have. Let me explain to you. I'll explain the problem. So, does this let me draw? Where is it? Where's just the draw tool on this stupid thing? Oh my gosh. Why I can never freaking find draw tool. Canvas, draw, online. Dude, all these things are so bad. Why is there literally just nothing that's... Oh my god, all these apps are so bad. Okay, this is what I wanted. So, you have your grid, right? Like this. So, from any point to any other point, let's say that there's an obstacle like in the way. Let's say that there's like obstacles here, right? Then the optimal path is ties can be broken arbitrarily, so this is an optimal path, right? But I need all pairs, all points from any start to any destination on this map. So, and I need the direction. So basically, the output of this thing I want to have something that tells me from any starting point which direction I need to move in to have the optimal path towards the end goal, which should exactly be all pair shortest paths. Does anything have less than n squared memory? No. Get out of the windows. Does anything have less than... Wait, every pair of vertices V. Am I wrong, or is running breadth first search not just faster? Wait. Pair of vertices. Am I dumb, or is breadth first search just faster? Let me see. Johnson's algorithm. On it's not sparse. Large grids. Dijkstra's that's not weighted. All pairs would be doing a lot of repeat. That's what I would think, right? But is... I would think that it's redoing a lot of work, but apparently this is not a thing. Like, I don't know if there's an algorithm for this. What's breadth first search is O of... It should just be O of n squared per call. This is the last search I'm going to do. Otherwise, it's just wasting my time. Could you not use the waypoint to your advantage here? Only really need the optimal path from a point in a particular region to the nearest way. So that's true for the creeps. But the advantage here is that, like, I'm going to be able to, if I have this, if I make this nav grid thing, this is going to be so much better because here, like, I can make you as a player, you can click a point and then it'll path there for you. Like, I can do stuff like that. I can make scripted agents so much more easily if I have this because pathing is just solved. And to be clear here, pathing is incredibly solved if I do it this way because, like, it's literally a lookup. Like, you, like, say, okay, I'm at this cell, I want to go to this target, I look up in a table, I look up the direction I go there, it's O of 1. So pathing becomes O of 1. Okay, ChatGPT produced garbage. It cannot solve anything. It cannot recognize when it has nothing to add. ChatGPT is garbage. Thank you for wasting my time. As always. Absolute garbage. Every time. Let's make this C-test thing. In that case, maybe you could compute that giant nav mesh once, but dynamically load relevant chunks into memory based on spatial position. Well, I was just going to mmap the file. I was just going to mmap the file. Though, frankly, like, I could just load it into memory. Well, yeah, I can totally just load it into memory, right? Yeah. So, the one trick I'm going to have to do is, like, you're going to want to simulate a whole bunch of instances of this game in parallel, right? So, like, here, a very common workflow that I'll have is that I'll try to get a batch of 4096 agents. So 10 agents per map. I need to run 400 games of 400 MOBA instances at the same time. And then usually I do that on a couple different cores. So let's say I have 800 MOBA instances. I don't want to have 250 megabytes per instance, right? I want to share it across them. So that'll be, like, mildly annoying to figure out, but not that bad. Let's stop yapping and start coding. We're gonna start with this in Python, and then we're gonna port it to C after that. It's not gonna be that hard to port. So what we're gonna do is we're gonna start with data equal Let's do, what is it? Def precompute pathing. And we'll do grid. And that's it, right? So, grid.shape 0. It's going to be square, so we don't really care about other stuff. And we can prune a little bit, by the way. We'll be able to prune just a little bit based on obstacles. So it'll be a little faster to compute. Maybe 50% faster. So we start with the grid shape. And storage. Was it optimal? What is it? Optimal paths equal dot zeros equal n times n. Nodes, uint 8. We'll do it this way for now. We might do bit packing later, we'll see. And what we do is... I don't like doing nodes like this, actually. I think it should be n, 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 and n, right? That's easier. Yeah, n, 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 and n. So it's going to be like, you know, x1, y1, or like y1, x1, y2, x2, something like that. For, what did we do? X and y. We'll do r in range of n, or c in range of n, and we'll do path. We'll do breadth first search, grid, paths of row and col, and then a row, comma, col. That's good. Turn paths, def breadth first search. Oh, is this just going to do it for me? I don't like that this is recursive. That's stupid. Actually, I think that's not just stupid, I think that's wrong. Breadth first search should not be a recursive algorithm. Right? Can breadth first search? No, breadth first search shouldn't even be able to be recursive, right? Did it just implement depth first search and call it breadth first search? It totally did, right? I'm not dumb here, right? This is... I just saw a tweet today, by the way, that's like, hey, next year the Math Olympiad winner is going to be a language model. Maybe we should start by teaching it first year computer science. That might be a better thing to do. Okay, so if the grid is 0, then we return. No, wait. Is 0? 1? 1 is obstacle, right? Okay. And then what we do is... Hold on. I'm getting confused by how I want to implement this now. The nice thing with breadth first search is it's always efficient. So the frontier is always the shortest path. We're exposing today how truly bad I am at algorithms problems and leak code style crap. So this is going to take me an embarrassingly long time, but I think the final result will be nice. So there is a lot of of work being recomputed here. But essentially what I want to pass is I want breadth first search to pass the first action that you took, so the first direction that you went in. So that whenever you get to a new node, you fill in the table with the direction that you took initially from the first step to get to that node. Does that make sense? So like when you pathfind from a specific starting point, the only thing that we care about is the first action that you took. Yeah. That makes sense. So, God. I think that you have to NQ the first 4 moves. Right? You have to NQ the first 4 moves. So it's going to be like move up equals 0. And then dr is -1. Column is 0. Move down is going to be index is 1. Left is going to be 2, 0, -1. And then move right. So this is going to be, these are your first actions. I was actually excited to do this today. I have no idea why I was, because I'm terrible at these types of problems. But it's going to be real cool when it works. This is going to be like ludicrously fast pathing. So, you have to enqueue all of these, I believe. And also, we're not going to be able to use this data structure, right? We're not going to be able to use this data structure. We'll do it this way for now, though, just to test it. We're going to have to replace this with, like, NumPy arrays. So while Q, move is going to be Q.pop. The new position that you're going to go to is the original plus, like this. And does this give you a stack or a queue? Wait, I think it's a stack by default, right? Yeah, that's a stack by default. So we're gonna have to do something because this will be depth first search, but we can shift it around a little bit. We'll just have to prepend. Okay, that's fine. Does Python actually treat them differently? Treat what differently? Stack and queue? We're using a list, and lists work as stacks, right? If you append, obviously stacks and queues have different methods. Well, this is neither. This is just a list. You can use a list in Python as a stack, just by default, because it has fast appends and fast pops. Well, fast for Python, right? But you can do like a.append 4, and then a.pop, and it's stack order, right? But then if you want to do it as a like, it's not fast if you want to use it as a queue. Doesn't matter. It's all slow because it's Python, right? But you have to do a equals, like, 4 plus a, right? And now this is a queue. Okay. Interesting. So it makes inferences about what? No, it doesn't make any inferences whatsoever. We're just... It's just the fact that lists have, like, this is not a stack or a queue, it's a list, right? And the way that the list structure is implemented, relatively for Python, it has O of 1, I believe O of 1 appends, and O of 1 pop from the end of the list. So that's what you need for a stack, right? Is that you append and then you pop, you get that same element, it's FIFO. If you want to do a queue, you have to, when you add elements, you have to add them to the start, and that is a slow operation. Python does have queues and stuff built in that we could use that would just give this us this anyways, but in reality, we're going to end up using a NumPy array anyways for all of this, because these operations are not Cythonizable, and we have to process 200 some odd million elements. So I don't want to wait for Python to do that. And Cython is fun. Okay, so if the grid is blocked, then we continue. Otherwise, yeah, I'm following now. I thought pop was taking out elements from the other end, and then when you appended it, swapped. To the... Oh, no, no, no. Yeah, no, it's not that smart. So, I think this is it, right? R2, C2. Yeah. Technically, the way we're doing this now, if you click on an obstacle, it's not going to work. But don't click on obstacles, right? Well, maybe we could fix that. Doesn't Cython work with deck? If it does, that's news to me. I don't think so. I'm pretty sure that lists and decks and all the Python data types will not be accelerated. We're going to end up having to... What we're going to end up doing is I'm going to just allocate a big NumPy array. And we're just going to, like... We're going to add stuff into it and then read stuff from the other side. A breadth first search, I think, is pretty easy to implement that way. You just pre-allocate a big buffer of however many elements that you need, right? And you keep a pointer to where you've written them, and you just keep writing down into the array. It's pretty easy to implement your own queue structure, so that's probably what we're going to do. Okay, so we set the grid to be the action. So what we're saying is that if you're starting at RNC and you want to get to this new position, then the first move that you take is action, right? PC, down. And then we append, move up. Does this do it? We're going to have to like draw this on a grid or something to see if it works. This is actually so critical to the code that I don't, and this is kind of a fun project, so I don't mind spending a little bit of time on this today. So we might even make like a cool little demo with it. Actually, I wrote a renderer over the weekend that'll be perfect for this, so this actually shouldn't even be hard to make a cool demo. And I think this is literally it. So, RC let's start with from 0, 0, right? So that we just run this once. And how are we going to do this then? So let's say that I think we can do this even more cleanly. Let's just write a little test function. So we'll do test BFS, right? And this will just take grid. And then this will take R1, C1, R2, C2. Then we'll do N grid.shape. And then we'll do paths equal, not this. We only need this one. We only need a 2D one. And then we do breadth first search from there. And then what we do is now we have to draw it, right? So we'll just do while the points are not the same. Loved your thesis defense, used it as an inspiration for my Viva. Not sure what that is, but thank you. Appreciate the support. We're doing some cool high performance. Well, not yet. At the moment, very low performance, but in a few hours, very, very high performance pathfinding for this new MOBA sim I'm working on for RL. It's like, what if we had Dota, but it ran at 1,000,000 steps per second? Okay. So, while the destination is not the start, then what we do is undergraduate thesis defense. Okay, cool, yeah. It's going to get a lot easier to work in this space soon as well. Like, it's going to get a lot easier to do work in this space because we're going to have a lot of these simulations. I'm working on building them. They're going to be way, way, way faster than ever before, and they're going to be way, way, way simpler than ever before. It's just going to be all good things all around. So what would we do? We do breadth first search, right? Yeah, so we do action equals grid of our is it possible to make a model that can be able to scrape the internet to get information about any person just by showing his image? Is it possible? Yes. Am I going to help you make a doxing tool? No. I think I did this kind of weird, didn't I? Well, yeah, because I can't actually get the optimal path from this. Yeah, right, because it's from the starting point. So you can't get the optimal path from just one call to breadth first search, the way I've implemented it, but you can get the vector field. So let's just get the vector field instead. Is it ethical to do? I mean, it's just like, that's clearly a thing that would be very, very heavily abused, right? Yeah, like you can think of a bajillion instances for like a thing to use that like would be fine for that, but that's just like, I mean, that leans more heavily towards missiles than, rocket ships to the moon, right? And mind you, I'm not usually somebody who cares a ton about dual use either. Like, generally, if I see an application that has a ton of potential for misuse but can also do a bunch of good stuff, I'll be very much in the camp of building it. That one seems like very obviously like I can't even think of that many good things that you would want to do with that. Okay, so we can't build this way. We need to draw a vector field, right? Let's just like draw a vector field, right? So obnoxious how this thing is. We have to write a little Raylib renderer now, don't we? Yeah, we totally have to write a Raylib vector field renderer, right? That's obnoxious. Well, it doesn't have to be fast. So that's not that bad, right? Yeah. Vector field is in every grid on the map shows an arrow towards the destiny. Yeah, like something like that. This is just this is just one of those cases where like I could YOLO it and just try to like run this, but it's very likely that I'll have messed this up and it's going to take me a while, right? So let's just do give it the grid. Oh, 16. Pathfinding from every node possible. Yeah, exactly that. This would not be considered very smart. This would be considered me taking 10 times longer than is needed on entry-level leet code bullshit. Unfortunately, I know how to build lots of cool things. I do not know how to solve tricky problems quickly. That is not something I am good at. So I mean the strategy to test in isolation instead of integrate. Yeah. And I don't usually write tests. I don't usually write like the isolated tests. This is one of the things where like you have to. You gotta test it, and you not only have to test it, you have to visualize it. I get to show this off now because we're going to use some of this code. I wrote this over the weekend. It's really cool. So I wrote this pufferlib ray renderer. Advent of code every year and pathfinding always screws me over. I mean, basically anything, any tricky algorithms problem that's unintuitive and that is only done quickly by people grinding leet code will screw me over because I don't grind leet code. Never have. Like you cannot say that these things are intuitive. They simply are not. So let's see if this works. I'll get to show off the render that I made this weekend. Okay, so this thing, right? Looks very similar to the one from before, doesn't it? Boom, we've got zoom, we've got fast zoom, we've got pan, we've got a little help menu. If I hit tab, that shows FPS and stuff. Excuse me, are you suggesting that there are more valuable uses of your time? Absolutely. Like making ridiculous MOBAs and renderers for them. So this is a nice little thing, right? Little smooth pan and zoom thing. Quits on escape. Here's the source code right here. That's it. Just this one little block here. It's pretty nice. Pause and then over a node to see the stats. That would be cool. That would be substantially more work. I think we can just use this thing and add some code, right? So well, this is wrong. It should just be grid.shape. It's completely wrong, actually. .shape 1, grid.shape 0, and then tile size here. Width equal grid.shape. Oh my gosh, this is so bad the way that this is. Here, width, height, tile size, times really wonky suggestions. Okay, there we go. That's the client. Client render, self.grid, right? Okay. let's start with this. And then what we're going to do is we're just going to add the vector field underneath it. What happened down there? Oops. Oh, yeah, this is garbage. We don't need this. Obviously, we need to do, we need to put some data in here, don't we? Why don't we... Let's load up like a crop of the Dota map. Let's load up a crop of the Dota map. That'll be fun. So here's your Dota map right here. Game map path is just going to be open Dota map. Don't need this. And then this is going to be of I don't like how this looks. Say was it 32? Oh, yeah. 16. Yeah. BFS takes well, this is called stuck in a while loop, I guarantee you. Yep, and that's stuck in a while loop, so that's infinitely looping code, which is wonderful. Ah, right. So this this array that we make, this needs sentinels. So we're gonna put this as zeros minus 1, and then we're gonna say if grid is equal to -1, then you continue. And this is why we test. What is the current state of the project? The current state of the project is pretty good. Oops, I forgot I have keyboard, not mouse control. So you've got your creep waves fighting. They fight each other reasonably. They attack towers. You got your 3 lanes. You've got heroes. The heroes aren't doing much. They're kind of chilling at spawn. I wrote this little renderer over the weekend. It is playable as well, though I think I might have broken a few things. We'll see. Oh, it looks good. Some improvements to be made here, but this is the current state of the project. I will save you, puffers. Here. And now we attack. We take the tower. And I die. Not bad for 1 week of work, right? I'm very happy with the progress. Apparently, this is not supposed to be R2. Is this supposed to be R2? Wait. Grid? Yes. This is supposed to be. This is supposed to be paths equal to this, and then this is also supposed to paths is equal to this. This thing is evidently still looping. $140,000. Yeah, that's too big. So, what do R and C represent? This is the starting position. So you breadth first search from a starting position. So let me see how this works. So you add action is move of 0. You add these in. You pop from the queue. Well, first of all, this queue append is wrong. Remember I said that this had to be breadth first search. So this should actually be plus Q. Do you need to be tracking visited nodes? Right here. Oh, wait. If it's equal to -1, this should be not equal to -1. Okay, that actually breadth first searched. That breadth first searched correctly now, but it quit very soon. Unexpected keyword tile size. Tile size. Unexpected keyword. Grid renderer does not take a tile size at all. I don't know how this happened, actually. Didn't I do the signature correctly before? Should be like this. Boom. Index 255 is out of bounds for axis 0. Super Maven got you, and you were talking so you didn't notice. Yep. Am I on the pro plan here, by the way? What is it? Plug. Was it upgrade? I don't know. What's the versioning thing? Plug. Update. Super Maven got updated. Okay, maybe it's better now. I don't know. We'll see. Super Maven Pro is running. Self.colors of grid. What do I have on the grid, though? Hold on, maybe I just have something dumb here. 0, 255. Let's see. So game map 2, 5. There. Boom. Aha. So this is inverted. Yeah. Hell yeah. Look at this. We've got our little renderer. And now we can do some breadth first search. Let's do 0, 0, and 31, 31. That's pretty good, right? Or no, it's 60. We did 60. So it should be 63, 63 maybe? Boom. Wait, no, you're still dumb. Aren't you? Because... Oh, R2 and C2 don't get used, obviously. So this doesn't even matter. But how, Feeling very, very quickly. So if the paths is not equal to -1, you continue. Okay, so we get R2, 1, 0. Paths is equal to 255. Ah, we made it a uint 8. A uint 8 is not good. So paths will have to be plus 255 will have to be our sentinel. Ho ho. That looks nice. Look at that. We got all sorts of stuff. Very nice. Though it doesn't seem to be correct. But at least we have some values. So now we got to draw some arrows. So we do R equal grid.shape of 0. C is equal to this. I don't know what it just even tried to fill in here. This is garbage. We need self.tile size. Tile size, right? And we do self.paths. Okay. And we need to do a draw arrow. Raylib draw arrow. Do we have shapes? We can do triangles, right? Mildly obnoxious that we have to do it this way, but this is correct, right? Oops. Okay, so mildly difficult. There's no draw arrow function? I guess there wouldn't be, right? So this is going to be... So it's going to be x plus. Damn it, this is actually hard, isn't it? TS. TS. Okay, so the positions we need to do. So x plus TS over 2. And then y is going to be the same, I think, right? And then it's going to be x plus 3, y plus tile size. Oh yeah, this is a triangle, right? X plus 2/3. Oh, yeah. Pause. 1. Now this position has to be down. So it's going to be Does this actually have it right? Do I trust Super Maven? No idea if I trust Super Maven, but let's do. Does it have a built-in rotate function? It does, but it has it for textures, I believe. So we're going to do rl.drawTriangle. And we're not going to do colors.violet. We're going to give it like a reasonable color. Which, why don't we use the... Oh, it's, I think 178 is puffer color. So R178, 178, 255. I think this is our color. Puffer color. And of course, we also have to do Raylib begin draw. Begin drawing. Clear background. No, we don't clear the background. We have to leave the background. Let's see if this does anything. Well, this is not quite what we intended. It's very flickery. I would love to know why it's very flickery. It's kind of cool. Can I begin drawing twice? What if I do it here? Nope, still flickers. No, it has a frame rate. But it should batch everything. At least I would think it should batch everything. We can give it a different frame rate. Well, now it does this. Oh, I guess it's, that's weird. Well, I know why it's happening. It's because it's the draw calls. There's an end drawing call in the render before this. So apparently it flushes after end drawing. Right. It's mildly annoying. I mean, for now, I can just patch this, right? I can just do... We can just do like this. This, right? And now it doesn't flicker anymore. Which is cool. And we can just not have the FPS be garbage. Which will be nice for being able to play with this. Ho ho. But unfortunately, I didn't remember to scale this. So... Was it scaled right at the start, though? Yeah, it should be scaled correctly at the start, right? Yeah. More or less. Let's figure out why the pathfinding is wonk. So... if the grid is 0, then what you do is you set the paths to 5. Set it to 5. And you continue. Does it do anything? Cannot access local variable pause. Continue. Now it doesn't draw anything again. Other way around, maybe? Oh, there we go. It looks like I'm offset a little bit, but this is what we want, right? Very close to it. Why are we offset one tile again? I think why we're offset a tile. So this is if it's up. X plus tile size, Y. X plus tile size over 3. Y plus tile size. What are the Raylib chords? I don't know why it's offset like this. That's weird. We'll figure that out in a moment. Can we figure out why it's all facing up? So we have this Q, right? Pop 0. Oh, wait, we can totally... Yeah, if we do pop 0 like this, we can totally use this as a queue. So we can do queue dot append move up, move down, move left, and move right like this. Still doesn't give us any unique actions. So very weird. Definitely should. Hold on. Yeah, so let's see. It's going to give us... So action is 1. Why is action 1? That's kind of weird already, isn't it? One, 1, and 0. What happened to move up? Oh, well, you can't move up, obviously, because you're in the corner. So that's actually correct. So we're left with move down and then move to the right. Yeah, that's correct. So what happens? Okay, the path is equal to action, right? Move up, down, left, right. Get appended. And now you have move left. Wait, you have move left? That doesn't sound right. Q.pop. Hold on. So here's your Q, right? Move. So the move is 1, 1, and 0. And then it's going to go through move left, and we should end up at move right. We do end up at move right. 3, 0, and 1. Okay. The path ends up being action. So that actually looked good to me. Let's see how the path looks after we have computed the path here. We can actually just do that right here. So let's see what our paths looks like. Ah. We do actually have various symbols here. I see a couple 3s at the top. Okay, and 3 should be moved to the right. So if action is equal to 3, maybe our draw function is wrong. Let me see. So the draw function for a move to the right, yeah, this is totally wrong, right? This should be x, and then this should be still x, y plus tile size 3, so 2 times tile size over 3. Right, and then we should have the last corner of the triangle should be x plus tile size. And then y plus tile size over 2. So this should be your correct triangle. Ah, that's better. So it's not perfect yet, but look. We see we have some triangle going on here. Something is reasonable over here. So let's maybe fix the remainder of these triangles. So 0 should be pointed down, right? So for a down triangle, x plus tile size. Well, these are flipped. Let's see if this is better. Okay, so this is now in the correct position, but it's still flipped. Let's see what's wrong with our 0 triangle. It's that Super Maven completely got it wrong. Okay. So x plus tile size over 2. Y. Wait. Yeah, this is just completely bogus, right? Yeah, so this is x plus tile size over 3. Y. X plus 2 times tile size. It's not that hard, really. And then y. Then x plus tile size over 2. And then y plus tile size. Do I still have this stupid thing upside down? I still have it upside down, don't I? Am I crazy, or should this be a down facing arrow? Unless the coordinate system's backwards, which it doesn't appear to be. This is where we're drawing, isn't it? Oh, apparently not. Thought that this was what the actions were. The heck are the actions? Oh, 1 is down. Maybe now? Whew. What happened? What happened? X plus tile size over 3. Y. X plus 2 times tile size over 3. Y. What the heck happened here? Five. So wait, this is x, y, so it's 5, 10, and then 8 and 6. This looks like a valid triangle to me. Why is drawing shapes this hard? It's ridiculous. Should not be this hard. Is it somehow the rounding? No, you don't. It's not closed. This should be fine. How to do it for this one? Is there like a rule of like the order you have to draw them in or something like that? Like maybe you have to draw them around like the right way? I bet you have to like draw them around the right way. Vertex in counterclockwise. Yeah, it's literally this. So it's counterclockwise order. So you have to go around the other way. So it's got to be 2 times tile size over 3. Tile size over 3. Well, if you think about it, it's got to know how to shade. I mean, I was correct. Look, it's literally the thing I just said. Right? So the obnoxious thing is I can't even tell you if this is wrong or not. Right? Because remember, this is drawing the first move. Okay, yeah, this is probably actually correct. Because the thing is, this is the first move. What it's drawing is for every position on the map, it's drawing the first move that you would take from the origin to get there, right? So yeah, all of the other positions, except the ones at the top, you can see that you have to go directly right if you want to go directly right. But the other ones are all like, yeah. I could give it a better starting position, maybe. Where would like a cool place to start this be? I don't know. I'll start it in the middle and see what it does. Okay, cool. So if you start it in the middle, which is like right here-ish, I think. A couple of these being empty is weird. But you start it in the middle. I don't know exactly where you start it. Let's draw a red square on that. And let's just do red rectangle to start. Okay. So little awkward that it's I don't know what's happening on the left here. Oh, probably just our left-facing triangle is drawn wrong, right? Yeah, probably our left-facing triangle is just drawn wrong. Which is which one? 2? So our left-facing triangle is... You start counterclockwise. So let's do x, y plus tile size over 3. Yeah, we just have to flip these. Graphics. Yeah. Awesome. Almost there. I would like to change... I'd like the initial position to be empty. So let's do that. Let's do... And this should be... We'll set this equal to 5. Which is our NOP. And then let's see. Okay, perfect. So... Yeah, this is correct now, isn't it? This looks like a valid breadth first search. So you have to remember, this is not the vector field pointing towards the target, right? This is, for every target position on the map, this is, if I start at the center, what is the first move I should make to get to that target? And I think that this works. So, okay, what we're going to do next is we're going to optimize this in Python first such that it will be easy to Cythonize. Then we're going to Cythonize it. Then we're going to get the actual maps that we care about. Let's do that. And we'll also rethink a couple little data structures along the way. But I think that I have it correct at the moment. Even though it makes it more awkward to draw, I think it's going to be easier to use. I'll be back in a minute and then we'll work on this. Okay. So it's occurring to me that we might be able to index a little differently. So right now I have it start position. It's start row, start call, end row, end call. What would happen if I tried to compute this as end row, end call, comma, start row, start call? What happens then? I have to slightly rewrite this then, because the breadth first search has to start from the destination, and it has to go to the starting position. That means, though, that a single breadth first search call gets me the optimal path to a target, which is more reasonable. And it should be better for cache coherency as well, because otherwise you're you always want to keep the first, indices or whatever the same if you can, and you want the last index to be the variable one. So if I do it this way, then the dest row dest call always stay the same. So I think it's better for cache coherency and it's better for visualization. Because it makes a lot more sense, right? If you think about it as you have a map that tells you how to get to every position, rather than you have a map that tells you the move that you make at any given position to get you to the next position that's closest. Yeah, that's way better. So let's refactor it like that, then we'll get a good vector map that'll be cool to look at. I can post that online. Yeah. This is gross code. This should be start R, start C. So we do backwards breadth first search. Let's actually break it out as well, because you can't do multiple lines. You can't multiple line it like this in Cython. Okay. And now we do if continue start R if it's not empty, start R is 5, paths of start R, it's going to be action, and now we have to flip these values, don't we? I think this is going to be backwards. We're going to see. Yep, so these are now backwards, it looks like. Worse than backwards. So let's first of all, we'll flip these. Now it should point towards the target. So this is how you get to the target, right? And now, instead of making it the first move, we're going to put action. This is 0, 1, 2, 3. I don't know why we worry so much about this. This is really just easy. I don't know why we worry about pathfinding. It's easy, right? Now, there's one minor little issue with this, right? Which is that technically, well, first of all, it gives you this really wonky pathing like this because it doesn't do diagonals. And second of all, like, these agents can technically move on a continuous grid. Yeah, they can technically move on a continuous grid, but we can do discrete pathfinding, right? For the creeps. Let's just, let's, like, add diagonals in. Right? Yeah, let's just add in diagonals. And that should be pretty much close enough, right? Because if they can just do diagonals, then, like, they should be able to learn, do the diagonal and then do the shortest, like, straight line or something. They're not going to be able to pathfind, perfectly. Not going to be able to pathfind perfectly, but it'll look pretty reasonable, I would say. It'll be really close. Is that going to look weird? It's going to look weird if they only move 8 directional. I don't think it'll look that weird. A pretty minor limitation, honestly. And this is just for scripted agents as well, and creeps. That's not a problem. That's fine. It'll look way cooler. Let's fix it. So, we actually get to make this way simpler now. Because all we have to do is paths is not equal to 255. Continue. Equal to action. Hold on. I'm trying to figure out a way to not have to do this logic twice. This is always the obnoxious thing with algorithms like this, is figuring out how to roll the initial condition into the main loop, so you don't have to write it twice and have it be gross. Let's see. So we can just, okay, I know how to do it. So we're going to get rid of this, I'd say. We're going to just have the Q be equal to 0, 0, 0, which is the initial position, right? And then what we're going to do is we're going to set this paths of dest R, dest C at the very end to be 5. So we just null that last action. And then what we do is we just, we pop from the queue, we get the action and the delta, start R, start C. It's an obstacle, set it to 5, that's good. You set it to be the action. Yeah, which is fine, it doesn't matter. And now what we just do is we just append lots of things. So q.append. So we're going to do action index is going to be 0. This is going to be dr minus 1 dc dr plus 1 dc dr minus 1 dr plus 1. So this is up, down, left, right. But we really want to do I like this up, down, left, right being like this. I'm trying to think if there's a clever way I can index this. It's 8 actions. Not really, huh? Well, that's okay. We'll just do it this way. So we'll do up, down, left, right. And then we'll do q.append 4, and then this will be dr minus 1 dc plus 1 row plus 1 all plus 1, then like this, something like this, right? Now the only thing we have to figure out is now how to draw these frickin' triangles. It'd be really nice if I could find a decent way of doing this. Let me think. There really isn't a good way of doing this, is there? I think I just have to write out all the bloody triangle definitions. Yeah. Well, that sucks. Yeah. So these ones were correct, I think. What if I just, like, let Super Maven do it and then I try to fix them? It's probably going to be slop, right? Yep, slop. Love my slop. Yep. Good job. Is there a function that I can use that will be just, like, better than this? I don't think so, right? Draw ring lines, strip, Bezier. No, I think not. Think not. Cool to see they have collision functions in there. I didn't know that. So is this let's see if these ones are still correct first. Oops. Else, okay, we gotta take this out. Hold on. Okay, so these ones are correct. These are just the straightaway actions, right? Kind of weird, but I think they're valid. And then we'll do if action is equal to 4. Remember, I have to go in the opposite direction of these, which is very confusing to think about. So dr minus 1. So it's pointing that way, so I have to point the other way. So, God, that's so hard to think about. 2 times TS Y X Y plus TS, and then hurts my head, plus 3. And this is supposed to be a 3. Okay. And 5 is dr plus 1, dc plus 1, so it points this way, so I gotta go that way. So what? That's... well, the first point is easy. It's just x, y. And then we've got to go around counterclockwise, which is going to be x plus 2 times tile size over 3, y plus tile size, and then x plus tile size, y plus 2 times tile size over 3. Okay, and then 6 is dr plus 1 dc, so it goes that way, so we got to go that way. Counterclockwise, so it's x plus tile size. What's this one? Yeah, 6, x plus tile size, y. That's the top right corner. And then we got to do x plus tile size. No, it's just x. And y plus 2 times tile size over 3. And then it's going to be x plus tile size over 3, y. All right, one more. So dr minus 1 goes that way. It's the bottom right corner facing 1. We flip it. Bottom right corner facing 1 is going to be x plus tile size over 3, y, x, tile size over 3, and x plus tile size, y plus tile size. Yes. Well, that's almost it. That's actually pretty darn good for a first try. I don't know why some of these are blue. Assumedly, I did something backwards. But these ones look good. So the one that's facing to the top right is not getting rendered. Top right should be... they're flipped, so it's the one that faces this way, which is 1 and -1, I think. So which one is this? 1. Which one's 1 minus 1? 6? Did I do 6 wrong? So 6 is supposed to face up, right? So I put it top right corner. And then I did x. Y is down here. And then x plus tile size. Much better. And yeah, only problem is that we're covering obstacles as well for some reason. So maybe let's not frickin' do that. If the grid... oh, we can't give it 5 because 5 is an action value now, so we have to give this 8. So we'll do our held out value will be 8, right? Okay, this is way better. So, is this perfect or not? It does allow you to go through corner-sized gaps in walls, which I think is kind of funny, honestly, that it allows you to do that. I don't really care about that, do I? If a wall is one thick like that, I can just touch up the map to have two thick walls. Did my bitrate just drop a bunch? Looks like it did. Hopefully we should be good now. Okay. So, something weird just happened to some of my arrows, though. No, I think they're good. Some are just not, they're not all the same sizes. It's no big deal. Nice vector fields. Maybe you can pad all obstacles. So in real time, the agents don't pass along wall. Yeah, that's what I was going to do. That's easy. I can just feather the walls. If I just feather all the walls 1 pixel, that will fix it. So I might just touch up the map, essentially. That's no big deal. Literally, you feather the walls 1 pixel, it's fixed. But this is nice. A good result. Now, do I dare try to run this on the full-size map? I think I do, right? Let me just see if I can do... So I set a big tile size for this, didn't I? Not really. This is 8. Let's do 8. Can we see what's going on here? Kind of. What if I now do the full-size map? Ooh. Kind of hard to see what's going on. Can I do like 12 maybe? Tile size 12? Maybe that looks better. Yeah, it looks better, right? Woohoo. And I should do like the enemy base, right? This would be a cool position to do. Which is like 16, hold on. 0.8 minus 16. Wrong way around. 128 minus 16. This is y, right? So I flipped y and x. So this is 16, 128 minus 16. And we'll do a little bit further in, it looks like. So this is like 20. Yeah. How to get to the enemy base. In your base, killing your dudes. You just follow the vector field from anywhere, right? So like this way, this way, this way. Yep. This way, this way. This way. This way. And we're in your base killing your dudes. Cool. Let's do... Let's do render.render. We'll do turn. I need to import the other thing from render, right? What is it? Hold on. We're gonna have a cool thing for Twitter. Renderer.render. C data to NumPy. C data to NumPy. Data to NumPy. Like so. And then we will do image, or this is a frame. Right? And then we'll do we have to import pill here, right? Import pill. Save pathing.png. Exit 0. I actually think, is it going to be... Well, the pathing is not going to change. Let's see if this works first, but I think that we're going to do something cooler before we tweet it. Do we get pathing? Yeah, so... Okay, so we've got that PNG. Well, we can tweet this first. That'll be nice. You gotta tweet more stuff so that people see it. Puffer marketing. Gotta do your open source marketing after all. Okay, so we get our pathing PNG. Let's see how this looks. Very nice. Okay. Cool frame. Good time to remind folks to start Pufferlib. If they enjoy this stuff, helps me out a whole bunch. We've got Will, who's going to absolutely refuse to end the stream before I do, meaning that we're both going to be here forever. Okay, so this is actually pretty solid. We now need to make this fast. Yeah, because this needs to run like 10,000 times, and I don't feel like this taking forever to pre-compute. Question is, how fast do I need this? So, literally all I have to do is use a NumPy array, right? Isn't it that easy? Because it's a queue, right? Yeah, stack would be A stack would be substantially more obnoxious, but because it's a queue, it's actually pretty easy. So we're going to give this grid paths. This is going to get a buffer. And let's take this buffer. So this is going to be kind of cool and instructive. This is how you make stuff super fast. Like 100x faster. Okay, so buffer zeros. The buffer needs to be able to accommodate n times n, which is the number of tiles, and then 3, which is the action row call, whatever. And it can't be a uint 8. And actually, I think I'm just going to make it a numpy.uint 32. Should be fast, right? Or just an int 32. I think that'll be optimal. Could make it a 16. I think it's usually faster to use 4-byte types. I could be wrong on that. So now we give it buffer, right? And now that it takes buffer, so what we're going to do is we just make a pointer, which is just an index. So pointer equal to 0, because that's where we're at right now. And we do buffer pointer equals 0. So we've zeroed out our initial, right? And then what we do is we're just going to do while true. Let's actually make this buffer be a -1. Make the buffer be -1s. We can do that, right? I don't know if we'll need to or not, but we'll do it. So while true, we're going to do action equals buffer, buffer pointer 0. And then what we do is we have action drdc. Don't need to increment the pointer just yet. Okay, now we can get our start R, our start C. These are fine. These are good operations. These are good operations. This is a good operation. The only operations that we have that are bad here are this q.append. Okay, so all we have to do is we now do buffer of pointer plus one. It'll be slightly more efficient to do pointer plus equals 1. Then buffer of pointer 0 is going to be equal to 0. 1, 2 is going to be dr action. I don't know where it got this 3 from. This is completely wrong. But this is the first update here. Like this. And this is dr -1, of course. We mirror this one. And then we do pointer plus equals 1. Could technically write loops over this. And you'll be fast. Well, we might write loops later. I don't want to have to redo the visualization stuff by reordering things. So we're going to do it the stupid way for now. This is dr plus 1 pointer. Let's see. So the third one it gave us was dr c -1, c +1, and then we got dr. See, this thing consistently gets shit wrong. So this is -1 +1 for 4. -1 +1. And then it is plus 1, plus 1, right? And then it's plus 1, minus 1, minus 1. I don't even know what it thinks it's doing at this point, but it's minus 1, minus 1. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So we will test this to see if this is the same as before. We also, did we increment the pointer enough? Ah, wait. We screwed something up here. We can't quite do it this way. This is pointer plus 1, like this. We can't increment the pointer like this, because we need the pointer to stay where it is. Okay. This is plus 3, plus 3, plus 3. Bear with me. This is going to be really cool when it runs like 100 times faster. Okay, and then I don't know why I just did that. My brain just decided to stop working. And then finally, pointer plus 8, plus 8, plus 8. Boom, boom, boom. And then at the bottom, we increment pointer by 1 for the next loop. Boom. Apparently, this was not happy with that. Forgot to break out of it. So, this is a reasonable way to break out of the loop. I would hope, right? Guess not. Would really think it would be. I should get a print pointer. Okay. So it gets 5. The pointer needs to advance. The pointer always needs to advance by 1. So this pointer increment actually should be up here. And then I need to edit all of these things, unfortunately. Right? Yeah. 1, 1, 1. 2, 2, 2. Of course, it's way easier to edit them than it is to add them. Okay, so that actually did run. But I think it did something weird. So let's do like this. So it did something weird. Let's see what it would have done weird. -1 plus 1 plus 1. Wait. -1 plus 1, right? -1 plus 1 plus 1 plus 1. So these all are fine. Pointer gets incremented here. Oh, you need 2 pointers. I'm dumb. Yep. You need 2 pointers. You need start and end. Okay, so you need, let me explain this. You need to have a start pointer that tells you where you're consuming the queue from, and an end pointer that tells you where the queue is done. And that's also going to tell you, you're not going to have to zero the queue out every time, so this is going to be even faster than I originally intended by quite a bit. But it does get, you do have to keep 2 pointers around. So you have start point, and by pointer I mean index. It's the same thing, right? Mm-hmm. So you do essentially while there's still data to consume, and then this is going to get rid of this ugly break condition here. Now this is end plus equal to 1. End, end, end. I don't know why it like keeps giving me these garbage suggestions. Okay. Yeah. Okay. Go, work, do your thing. Damn it. This shouldn't be possible, right? Yeah, this shouldn't be possible because I allocated enough space, essentially. I allocated enough space for every single tile to go into the buffer. So if this is not working, it's because... Why? Plus equal to 1. I don't know, actually. It looks good to me. Buffer start is 0, end is 0. You add 1 to the start. You don't add anything to the end here. This should be action. Wait, should this be action, or did I totally screw this thing up? Wait, what? This isn't action at all. This thing gives me garbage suggestions sometimes, and it screws me up. Like, I'm not going to uninstall it because it's really, really nice for the code complete, but the models actually have to get a little bit better. I wouldn't think this will make a difference in terms of it not running, though, right? Yeah. It's still going to screw up if it's going to screw up. I don't know. Print, start, comma, end. Something. That tell me anything remotely useful? Tells me the start is keeping up pretty well with the start's keeping up pretty well with this thing. This should not be possible here. Because I give it grid shape, right? And then the buffer is n times n. I don't need to subtract 1 anymore. I'm not using that as a check. Oh, and you should also return, you should return end as well. Wait, end plus, hold on, does this make sense? Or am I overwriting? I think it makes more sense to start this at 1 and do while start is less than end, and then I put these as postfix ops, right? Yeah, that'll be nice because I'm gonna want to return the end so I know how many elements I have. So we'll do return and like this. That's still not gonna fix it though. Yeah. So why? Let me see. So you get the action from start, right? You get dr and dc from start. Okay. You go start r here. You bounds check it. You I also don't know why I'm doing it this way, right? Like, This dr and dc doesn't need to be this way. I can just do, this can just be start r. So this should just be like buffer zero equal 0, I guess. And then we do buffer start1 equals dest r, and then dest c. And then this is just start r right here, right? This is start c. So this simplifies because we don't need this garbage anymore. Yeah, because then you just directly do, this is just start r minus 1, start c, start plus 1, start c, start r, start c minus 1, start r, start c plus 1, start r, see? Almost just did it right there. Start r plus, start c plus 1, plus minus, start minus 1, start minus 1, okay. Still not going to fix it. Makes it cleaner, though. Now, aside from us being able to roll this into a loop, if we reindex our actions or reindex the triangles for drawing, so this will be one little loop, like over R and C. Maybe. We could also just leave it unrolled like this. But aside from that, we're pretty much optimal. Oh, and the issue is just that the buffer isn't big enough, right? Because you can add the same tile in multiple times. You just can't... Yeah, you can add the same tile in multiple times. You just can't actually pick the tile multiple times. And I think that the most number of times you can add a tile in is... Hold on, it's 8, right? So I think it's the buffer's actually got to be pretty freaking big. I think it's 8 times n, which is, you know, a little bit obnoxious, admittedly. Boom, we win. Okay. So you might be wondering, why the heck did I just do all of that, right? I just spent a bunch of time to make the program, I'm going to tell you right now, not even any faster, to refactor it in that exact weird manner. So the reason that I did that was that now it's going to be trivial to Cythonize. And the way I can tell you that is I just wrote this thing in a way where every single operation is going to effortlessly translate into pure C with no reliance on Python whatsoever. The prerequisites for that are mainly that you're not using lists or decks or anything like that, or tuples, any Python data structures, and that all of your operations can be expressed as loops over NumPy arrays. And if you do that, you're good. So let's do let's have a little fun with this. I think we've earned it, right? You want answers? I think I'm entitled. Alright, so we don't need all this garbage. This is garbage. Get rid of the garbage. Alright, and now this is a CNP cdef.nd array grid. Can we type these? I think we can. I don't know if we can type these. I don't know if we can type these. We should be able to, right? Yeah, let's try it. Grid cnp.nd array paths cnp array buff, and we got int. Yeah, this is an int, returns an int. We cdef int n, int start, kaboom. Start. Now we also have to do, of course, these start R, start C. And what I like to do is, just to avoid bad variable names, is I just like I postfix these np like this, right? And then what I do is, well, first of all, I don't know why I did this. This should just be a block like this. So we get cdef int, and int like this. And then we can cdef this is, we have to go get the types of these. I think it's it's char for grid. Char grid is grid np. I think paths is also a char. And then we use an int for buffer like this. Okay. So let's check this. And now what we get to do is we get this pix import, right? And then we do, oops, from C precompute import bf as cbfs. And now what we do is we get to just do cbfs. Let's see why no Cythonize. Expected. Did you use cdef syntax and use decorators and Python type annotations instead? Okay, so that's slightly awkward. One of the limitations, I think. What if I cpdef it? Does this work? Okay, return -1. Give this an opcode. Okay, so we have a Cython. It is Cythonized. Now we'll have to figure out why it doesn't work. Figure that out pretty quick. Buffer, zeros. Buffer has only one portion of data in it. And after that is empty. So let's see why that is the case. Did I get the data types wrong? We've got paths as a numpy uint 8. What did I have game maps as? Is game maps the wrong type? That could be. D type uint 8. Okay. So this is fine. We just have to figure this out. We'll do print start, or was it start end? Okay. 1, 1. Well, that's not good. Paths. If grid of start R, start C is equal to 1. This is the exact same code as before, is it not? We managed to make the this version work and the other version not work, let's say. Yeah, so right now the Cython version does not match the Python version. Somewhere. It does appear that it is getting overwritten. It's getting overwritten somewhere. Action is equal to... Print start R, start C. Print paths of start R, start C. Print grid. These are the 3 possible options, right? I don't know where else it would be breaking. -1. That's very odd. What did we give paths? Char? Ooh, that's disgusting. Is it an unsigned? I think it's an unsigned char, which we shouldn't have to sign it, but okay. Char should already be unsigned. There you go. Okay. Gross type bug. Unsigned char. You gotta be careful. So let's recompile this. And now let's check the, do we have an HTML file in here? We do not have an HTML file. So what we're going to do is we're going to recompile this such that we get HTML out of it. And then we're going to enable all of these optimizations. Whoops. So we're going to go up here, and now we're going to tell, we're going to instruct Cython to compile this with absolutely no safety features. It's not going to check values for none. We're not doing any division, but if we were, actually, since we're not doing any division, we can get rid of this one, and we can, yeah, we can leave these like this. So this is now doing absolutely no safety checks whatsoever. We're going to add this to the setup file here, and we're going to turn on this annotation option. And hopefully this should output us a very nice file that will include for us a detailed profile of this code and anywhere that I've screwed up and have made it slow by mistake. Of course, since I just pulled in all the changes from this weekend, it's recompiling everything. But, you know, you win some, you lose some. Okay, so perfect. We see we have this HTML file here. Precompute pathing HTML. So I have to, just because I'm on WSL, I have to move this into Docker where I can get access to it. And then if we look at C precompute pathing.html, so we can see that this function signature, because it's cpdef, it'll call back to Python. No big surprise. The initial memory view will call back to Python as well, but we're going to have a way around this when we call this in a loop, so no big deal. And then, beautiful, I did it perfect on first try. The fact that this is all white and has no annotations means that this entire code, this is a pure C call. It's a pure C call, and this is, we can see right here, this is just array indexing. So it's just straight up doing, you know, array indexing math, which is very, very nice. Yeah, that's perfect. So let's, how fast do you think that these are versus one another, right? What do we think? I have profiling off on this, I believe, which is what we want. Let's do a perf test. Okay. So we're going to take this code right here. And this will be grid R2. You don't need R, you just need C, right? Okay, so whoops. Import time, start is time.time. While time.time is less than start. You can do BFS. Iters equals 0. Iters plus equals 1. See, iters equals 0. Start time.time. Wow. CBFS. C iters plus equals 1. Perfect. And now what we can do, test performance. And hopefully this runs for us. And we will see how much faster this code is. Should take 20 seconds. If it takes longer than that, then I will be confused. Nope, there we go. Okay, perfect. So iters divided by timeout. Hold on, iters. Grid paths buffer. I'm not believing that. So it says the C1 is 10 times faster, which is about right, but I don't believe that the other one is so fast. I'm worried that it is just doing the first. Right, you have to null the grid every time. Yeah, you have to null the grid every time, I think. Or is it the paths or the grid that you have to null? You have to null the paths every time. Paths 255. And the buffer you shouldn't have to null. Okay, let's try this again. Because the thing is, I wouldn't have bothered automating it if it were running 145,000 steps per second. I wouldn't have bothered Cythonizing it. That's fast enough. That'll like do the whole thing in a second. But I think you're going to see that there's going to be a significant difference. Yeah, that's more like it. So, yeah, that's what we'd expect. Is that C number right? That seems really fast. Could very well be. Yeah, because this is not just C versus Python. This is like... Oh, no, wait. This is straight up C versus Python. 1,000 times faster? That's pushing it, isn't it? Isn't that pushing it? 1.6 steps per second. Same exact code, so it shouldn't be. Well, I don't want to post this yet until I'm positive. Because whenever you post something, oh, it's like 3,000 times faster or whatever, and then you're wrong, you look really stupid. So we're going to let this, we're going to work on this for a bit. And if it looks like it is actually that fast, then we're going to go from there. Okay, now, so perf test is set. If that is actually the performance difference, though, and people are still writing this type of stuff in Python, like, get out. Prototyping it in Python is fine. Hey, Roman. Welcome. We just made breadth first search really, really, really fast. Here's your breadth first search. It's a really fast. Is that like ballpark reasonable though? Because let me think. This is order of like 10,000 tiles. 10,000 times 4,000. Oh yeah, that's totally reasonable, right? It's like tens of millions of steps. Yeah, that's totally reasonable. That's actually very reasonable to expect out of C. The Python one being this slow is... also kind of reasonable, to be honest. Python, like, loops end up... whenever you're doing anything with, like, any logic plus loops, it goes from tens of millions to, like, tens of thousands at most steps per second. So you do lose a lot. Slow language. Slow language is slow. The nice thing about this is we should be able to pre-compute this entire thing now, like, stupid fast, right? Yeah, we should be able to pre-compute this whole thing really, really stupidly fast. And I'm not even Cythonizing the outer loop yet. So we'll do, this is going to be CBFS, grid paths RC, the starting point, return paths, and we're going to do paths numpy zeros. Isn't it n? How much faster it goes when it's recomputed? What do you mean how much faster? Oh, pre-compute. Well, I'll tell you how much faster it goes when it's pre-computed. It's the difference between being able to do this and having it be O of 1, or having to do this and having it be, like, completely unusable. This alone, I can tell you, this operation alone, if we tried to add this into our code, even if we Cythonized it, it would limit us to like, well, you have it right here. Technically, let's say we can get this down a fair bit with A star. This is only 4,000 maps computed per second, right? So if we're going to say A star versus full breadth first search is much more efficient, let's say that we get this down by a factor of 10, so 40,000 steps per second. That's still, we're only able to do 40,000 pathfind searches, right, per second, times like a couple hundred minions. We're now down to hundreds of steps per second on our entire simulator. And I mean, maybe you can cache it and only pre-compute every so often, but still, like, we're going to be down to like maybe thousands of steps per second on our whole MOBA just because of this one operation. Compared to what we're doing right now, this is O of 1. This is nothing. This is instantaneous. So we've basically taken our pathfinding from being a bottleneck that's going to make this entire sim cap to thousands of steps per second to free. That's what this has done. I don't optimize stuff just for the sake of optimizing it most of the time. I optimize stuff when it's going to make a massive difference. Okay, so we do pre-compute path thing. And then we paths equals this, right? Yeah. Is very big. Absolutely massive. Okay, so we got our pre-compute pathing here, which is a very nice little function. And what are we going to do with it? We're going to call this function here. And I did not mean to do it here. This should have been up here, right? So these can go back where they are. We compute pathing. Let's do... I don't know. Doesn't need this R1 and R2 anymore. So we'll do like this, right? And it's grid.shape. Don't need any of this. We just pre-computed all the paths. So now what we get to do is render.render. We can do paths of R1 and C1. Let's see if this works. Oh boy. That's not what we wanted. Well, this is all zeros is what just happened here, right? So it's possible that this was this a bad tile? Hold on. Nope, that should be fine. Pre-compute pathing. Paths row call. It just mirrors that really weird. Do we need to clear buffer as well? Do we need to clear buffer? I don't think so. I think I intentionally designed this so we don't need to clear buffer, right? Yeah, there's 0 checks on buffer. 0 checks whatsoever on buffer. Though technically there will be garbage in at the end of it if we don't well, there could be garbage at the end, but we actually don't care if there's garbage at the end the way that I implemented it. So yes, this is actually a very smart implementation. The way that this is done. So why then is this not working? It runs real fast. Whew. That takes a long time to run NumPy unique on this data. Well, I don't think we're getting our 4,000 because it's not actually running appropriately on it. Let me see. Oh, we forgot to do... I think we forgot to add to our paths, right? Plus 255. Oh no, we're still fine. Yeah, we're still fine. We just forgot to add it here. We're good. Very nice. So, this is not an amazing use of time, but I kind of want to do something fun. So, we're going to do something fun. I don't think it'll take me very long. I want to make this reactive. So, where's our Raylib code here? Render.render. Start R, start C. No. We don't do start R, start C. We make it dependent on the mouse. X, Y equal. Hold on. Takes one positional argument, but 3 were given. This follows me around, but the map doesn't change, which I do not like. So let's figure out why. Self.paths. This is end R. End C, right? The way we did it. So end C. End R. And then this is end R. End C. Wait, action. No. This is paths of RC, and then what we do is paths equal self.paths. Okay, there. Boom. Work. Invalid index to scalar variable. I do not like invalid index to scalar variable. Raylib vector field. Where is this stupid thing? Precompute pathing, paths. Right here. This is, you need all the paths. Boom. Okay, tell me this isn't frickin' amazing. Tell me this isn't frickin' awesome. If you go over an obstacle, it just immediately, you can't path there. Tell me that isn't like the easiest ever to make a UI to do like ridiculous real-time. This is technically real-time pathing, by the way. This is like This is how fast it would be to, like, literally the map is the lookup because it's all pre-computed. Look at that. Whew. Rite of passage to make your own real-time pathing demo. It's so cool how it changes as well. Like, you can see, like, diagonals and stuff will change a little bit as you path around. Yeah, there's a lot of redundant information here, but who cares? It computes, like, freaking instantly. I wonder if this computes fast enough for me to, Oh, I have an idea. We're going to get this so fast that I don't even have to ship the file. We're going to get this to be so fast that it's just going to, we're going to make this map on startup, and it's going to be like 0.1 seconds or something to pre-compute all of these, and you're not going to notice. And that's just how we're going to demonstrate software superiority. Damn, this is awesome. Can it be fast enough that you can make them? Make them what? Path around other creeps and players? Nope. Not even close. So I think I can see why you would think that, because you say, oh, look, it's really fast. Like, if you can make all these maps in less than a second, surely that's really fast, right? But, like, do you understand how fast the game is going to be running? Okay, let's say that I'm going to get a minimum of 1 million agent steps per second. Okay, so that is 100,000 game steps per second, because they're 10 players. So I said 1 million steps per agent steps per second is 100,000 steps per second of that. I currently have the frame rate set to 5, I believe. It's like 5 steps per second. So we're going to do over 5. That's the number of this is the number of seconds worth of gameplay that we're simulating every second on one CPU core. Divide by 3600 means that we are simulating 5.5 hours of Dota per second on one CPU core. That is how fast this thing is going to have to run. I like to do that once in a while, because, you know, when the performance numbers get to be ridiculous, you can just keep saying bigger and bigger numbers, and everybody will just say, oh yeah, well, that's pretty fast. But then when you say, no, I'm simulating 5.5 hours of Dota per second on one CPU core, then you get it, right? It's pretty cool. It's pretty cool. What did I want to do with this? There was something else I wanted to do, right? I wanted to save a GIF of this. Oh, no. I know what I wanted to do. So, when I put it that way, it makes sense, right? Like, the thing I'm building, it's way cooler when you understand that is the level of performance that I'm going for, right? Like, games are not made to be this fast. Like, games are made to run real time, or maybe 10 times real time, so that it runs on, like, low-end hardware, right? This is... Here. Where is it? Actually, we know right here, just by this division by 5. This is made to run 20,000 times real time. That's what we want. It's going to take some performance engineering to get there, but that's what we're going for here. 20,000 times real time. I like performance engineering. It's very performant. Want to see something cool? We can put the loop in Cython. This is gonna be a CP. No, this is gonna be a def that takes a grid. This is gonna be a CDEF, meaning it runs 100% in Cython. This is gonna be. I think we do want to. I think this will be a CP def so that we can type it like this: CNP NP array grid. Because we're gonna do CDEF like this. Okay, and then we have passed in these memory views, which are now going to be grid NP. I think we can just do like this, unsigned char. And then we can do unsigned char. They totally screwed up my indexing. So I'll type it manually. Paths. Okay. And buffer. That looks good. Grid, paths, buffer, row call, and RNC. Oh, int RNC. We get rid of all of this garbage. Def. Like so, right? And, you know, now we get, precompute pathing here. So, we can do import. We can't import this anymore. We can do precompute pathing as C precompute pathing. And now this is just breadth first search, right? And this will be even better for timing. Though I don't even know if this is going to be reasonable to time because I think that the Python version will be too slow to run. Isn't that funny? But yeah, so we're going to do C precompute pathing. We'll have to fix some minor bugs, I'm sure. Precompute pathing. Right? We get rid of these NumPy variables. These are now typed correctly as unsigned char view grid. This is unsigned char paths int buffer. See? Grid is declared after it is used. Because we need this one to be NP. And this one says CBFS, where it should just be BFS, because we're in C. And what else? Paths. Cannot convert unsigned char to memory view slice. Well, that's because this is just stupid, and we have to index this way. Cannot impute precompute pathing. Precompute pathing from C precompute pathing. This has to be a CP def. Look at that. So we have our same code working as before. Let us time the function. How fast is this? Is this fast enough for us to do stuff with? Precompute. Or do we have to cache it? We might still have to cache it. Let's see. It's a lot of data. 3 seconds. So we're going to want to cache it. But 3 seconds. It's pretty good. 3 seconds is pretty good. Let's make a GIF out of this for the Twitter. This is some performance engineering. So actually, based on that, we'll be able to tell if this was correct, because this is, what did we say? Python 128 times 128. No, wait. Yeah, this is the number of maps divided by 3. Oh, it's even faster now. It's 5,400 steps per second. Because I automated the outer loop. Right, so we're no longer remaking the data constantly. That's pretty darn good. So like 3,000. So like 3,000 times faster than Python. What about this paths colon equals? Oh, yeah, we don't need that in the main test. We're good. We are good. And how much data did we say this was? Because I saved it as char, right? So it's 128 times 128 times 128 times 128. $268 MB. 268 megabytes. That's ridiculous. 268 megabytes of pathing data calculated and generated in 3 seconds. I'm liking this performance engineering thing. I'm liking it. How do we do this? It's this thing here. So let's do it like this. Let's set the FPS to 30 maybe. No, that's still going to be way too much data at this resolution. We'll set the FPS to 15. Where's FPS on this thing? Raylib init. Okay, we'll set the FPS to 15 on this. And we'll do frames. Frames equals like this. Before I in range. 6 seconds of data is 90 frames. Frames.append. And then we'll do recompute, or just do pathing.gif so I don't overwrite anything by mistake. Loop equals 0. Cool. We'll see how that GIF looks. Man, lots of cool stuff here. Lots of cool stuff. Oh yeah, that's a great GIF. 6 MB? Perfect. We'll do one more try. I want to get something real cool looking. Nope, screwed it up. Try not to hit the edges. Gotta not hit the edges. Right here. That's pretty good. I thought I just fixed it. Is this not the right one? Yeah, there we go. There. Let's put this up. Hmm. 100 lines of Cython. Let's commit this and can I like make this? Can I just make the terminal font smaller? I think I can just make the font smaller, right? So I can put it in a screenshot. Not quite. Almost. It's not going to be readable in a screenshot if I do this, will it? We'll do it anyways. May as well. Oops. Let's do star puffer. There we go. There we go. I'm happy with that. Seems Will has gotten bored and has stopped streaming, meaning that I win for the day. Okay. Well, this is awesome. I'm very happy with this result. This didn't even take that long, right? This took, what, 4 hours? 4 hours of streaming? Is that how long we've been live? From scratch? So we're going to get to integrate this now with the MOBA, obviously. I'm going to take a couple minutes. Going to go use the restroom real quick. Going to make a shake. And then we're going to integrate this with the MOBA. And we're basically just going to have massively overpowered pathing. And we can actually have high-level commands now. Like, we can write a function that's just like, path to, or like, move towards. And it can be anywhere on the map. And that function is now O of 1. And we don't even need to, like, save, like, destinations along the way or anything for it. It's just, it'll just do it now. So that's real cool. Anyways, I'll be right back. And, I don't know, go like this if you want to help with the promo, and Star Puffer if you haven't. Helps me out a ton. Be right back. Anybody ask where I am, tell them I'll be back in a moment. Hey, Will. I don't know if you're still there. If so, how do you like this? O of 1 pathing for the entire game. This is what it's going to take to fix reinforcement learning. We need simulators that care this much about perf. If we don't have simulators that care this much about perf, RL is just going to be slow, and you're going to have to be Google in order to do it. If we have simulators that can be as complex as, like, I don't know, strip down Dota, this is the goal here, that actually really care about performance, and you can never be bottlenecked by them, then we're looking pretty good. Then we're looking really, really good. So, we're going to integrate this. Yeah, we're going to integrate this. We might even make some scripted AI, because why not, right? We can basically now reuse the creep AI for the heroes, and we can have them just run at each other. And then we'll see from there. I'm probably going to spend 3-ish hours on this right now. So let's get the pathing integrated first, so that we actually get this in the main game. I think we are going to cache it as well, but we're not gonna distribute a 200 megabyte file. What we're going to do is we're just going to cache it on startup. Right? We're just going to cache it on startup. Okay, let's fix these, what is this? This tiny font. I think it was 16. Oh, geez. This now needs to be the correct size. Boom. Okay, good. Let's commit all this code as well. So you guys can actually have this if you want it. What the heck? Oh, the follow buttons are leaking from over here. That's fine. Just wondering, the stream looked weird. ultra fast. Let's do, was it from C3 pathing import and then this just takes a grid, right? This game map is a little wonky. Pre-compute pathing. I think we had to modify it, right? Yeah, right here. So, what the heck? Where's the call? Oh, right there. Game map pathing map equals, we'll do it this way for now. Game map.copy pathing map 0 is equal to 1 and pathing map equal to 255 is equal to 0. We'll leave it like that for now. And now we do pre-compute pathing. And this is going to return pre-compute. Returns paths, so paths equals AI paths is going to be this. Self.ai paths. And actually what we're going to do is we're going to do AI cache path pathing cache .numpy. Okay. Try. Except ohm. That looks good, right? And then what we do is man, the C environment right here. Self.ai paths, right? AI paths. AI paths is like this. I don't know why these don't have, you know, these things on them as well. This should be CNP. Should all be typed. It's just like asking for bugs in Cython not to type them. Cython doesn't always interpret stuff right if you don't explicitly type it. And unlike, you know, most compiled languages, it will actually, not typing it will cause runtime errors. So now we do self.ai paths. And where did we do? This completely got it wrong. It's 4D like this. And then what do we have? Move to Interesting. Engage AoE. Yeah, man. So we need to just make a method path towards, right? Is how it's going to go. Move modifier, agent speed. Towards. Okay, so it's going to be entity, destination, and we need a float speed, right? Yeah. This is good. And do we want to give it the integer here? I think we want to give it int dest y, int dest x, because if you already have it computed, you don't want to redo the cast. So, shouldn't be that hard. Int entity y, x, so then we do speed equals, what's this clip? Oh. Clip to -1 and 1. It's kind of weird. Move modifier. Okay. And now what we do is int action self.ai pass. That's exactly what we want. Okay. Dx, dy. And now we have to do this obnoxious thing. So if action equals 0, and we will, we have to flip all of these, which is the obnoxious portion. Because this is how you go away from the destination, so we have to flip them. So if action is equal to 0, then we do dy equals 1. If action is 1, then we do dy is -1. Then dx is 1, dx is -1. And let's see. So this is, it goes minus and then plus, so we have to do plus and then minus. And then it goes plus and then plus, so we have to do minus and then minus, right? And then we do for 7. We missed one of these somewhere, so that's not good. Let me see. 3. So 4 is, we missed one with 4. So this is plus and then minus, right? And then this is plus and plus. And this is minus and plus. Minus and plus. And then plus and plus. And we did something backwards because I see 5 here that I have, plus and plus. This one's supposed to be minus and minus. Let me double check these because it's very important that I have these correct. They should be all flipped from the originals. So this plus and plus goes minus and minus. This minus and plus goes plus and then minus. This one is minus C plus C. Yeah, so I have all these correct. Okay, so now what we do is entity.x, entity.y. Actually, we need this move too, right? So we do float dest y, float dest x. Do this. Dest y, dest x. And then we do move to, I think. Int move. How do you deal with eye fatigue from looking at this monitor for long periods of time? Oh, geez. I've been doing this for so long that I no longer get eye fatigue from looking at a screen. I get eye fatigue from going outside. So basically, even if it's partially cloudy, if I'm outside, I'm wearing sunglasses. That is the reality of things. Does this thing take into account move modifier? No, it doesn't. I think this is good though, right? And then we can make this a bint as well, right? And we can return move to. That's really nice. So now with this creep path thing, right? We can replace this whole thing with if grid disk is not empty. Wait, and I think this is fine. So what we do is we do move creep y plus dy. Wait, creep path. Can we just replace this whole function? I think we can replace this whole function. I think I can just go like this. Right? And then I can just do yeah, literally this, right? But I do need this clause. This is the end waypoint, right? Yeah. Okay. Invalid index type float. Invalid type float. towards. I specified this as... What the fuck? AI paths. Dest wide. These are both ints, buddy. What's wrong with you? Invalid index type float. Move towards. Am I dumb? Int dest y, int dest x. That looks totally fine to me. Hold on, is it maybe... No, this is self-agent speed, right? You call it with creep, agent speed, int of dest y, int of dest x. Did I redefine the variable somehow? No. That's freaking weird. Is there another bug up here? Oh yeah, there are bugs up here, that's why. Clear. Nope, not that one. Clear. And build. And we still have the bugs up here. Float dest y, yep, redeclared as expected. That breaks shit. Dest y is going to be entity dot y. Wait, entity y. dy times speed. This is totally good. It's totally good. What other bugs we got? Cannot assign type float to int. Yeah, so we're gonna just one line this then. Entity.y. Entity y plus dy times speed. Okay, we're gonna just like this. That's nice. Obviously, we gotta delete these guys. Builds. Builds. We dropping frames? What's going on? No, we're good. Free invalid next size. Aborted. Really? Do I have to do... I have all the checks on. Right? Do we have anything in here that tells us anything? Invalid next size. Normal. These things have type checks on them, don't they? These memory views? I would have thought that these would have to dy. We're gonna do this, and we're gonna see if we get any values that are like wonk. We didn't get any of these, did we? So, I mean, if we're not getting any of these, is this thing aborting even if I just do it like this? Like what's going on here, right? Okay, so it's aborting this even though we haven't changed the freaking code. So let's go figure out. I'm sure that there's some weird jank thing in here, right? Compute path. It's possible this is looping or some dumb shit is happening. Let's see. No file. Pufferlib environments, ocean MOBA pathing. Okay, that's fine, alright. Except gamemap.copy, set. Do we get AI paths? No, we don't. Okay, let's see what the hell happened. Apparently our pre-computation code was working fine before, but it was not working here. Game map.shape. So 128, oops. It is a 128 by 128 game map. Game map, I should say. One 28 by 128. Uint8. Ah, well that would be that. Well, there's your problem. Pathing map. So this is the original code. Expected numpy dot ndarray got memory view slice. Interesting. Well, that's not bad, right? Try this. Okay, there we go. Here's our game. We can play it. Yada yada, right? GB valib. And now what we're gonna do is we're gonna try to change some shit. X towards. All right, and now move towards is gonna be like this. Nope, stop freaking giving me bad suggestions, autocomplete. And layer. Build this. Build this in place. Ooh-wee. Well, Python's a bit wonk, isn't it? Why is this pathing to here? Very weird that this paths to there like this. That the neutrals are also pathing weird. Is it possible that the pathing directions are wrong? I never see them turning, which is weird. This one right here you'd expect to turn. So as for the towers, right, like... No, this they should path around this. Let me see. Why is this one going this way? It's possible I just have the actions all flipped, right? Well, these two go totally wrong direction. Okay. Where do we update the waypoints here? If found target, else, creep path, L2, waypoint. Move, creep, agent speed. So we have move towards. Wrong order. Dest Y, dest X, entity Y, entity X. There we go. So now let's see. Decent chance we get something more reasonable. Ever heard of probabilistic programming? It refers to the probability that your program works the way you intend it to. Okay. Ooh, look at that. Look at this snake action here. Ooh, look at that. That's sweet. So they're getting stuck on towers because towers are not included on the base map. But look at this, like, that's some really freaking cool movement, right? Yeah, and then they like perfectly. It's a little funny that they perfectly bump into each other, so we're gonna probably want to jitter it a little bit. But that's so cool. Look at that. Okay, towers. Tower positions. Let's add some jitter and then we'll do tower positions. It's alive. Yes, it is alive. Rah. Do I not have a jitter in here? This thing here? Let's do jitter X maybe. float x float jitter y times speed. So you do 2 times speed. I don't think you need these spaces here either. No, you like these spaces. These are good. Perceptually grouped. So agent speed. Oh no, but it should be the 2 should be grouped here, right? Because it's 2 times thing minus 0.5. Yeah, so this is the perceptual. This is how it should be grouped. And then what we do is we do jitter at y, jitter x. I don't know. We do it this way, I guess. Let's see what that jitter says. Agent speed. What the? I love it when it makes up variables that are just not in my freaking code. My favorite thing, man. And I think I wanted to do this first, right? We can do this. Let's do it that way. That way we have modified by speed, because otherwise it's going to be weird. Okay. Boom. We had a little jitter to the movement, which, to be fair, I'd prefer not to have to do. Oh yeah, that's way better. Look at that. They go right around the towers. It's a little too jittery, isn't it? The neutral creeps are behaving a little weird. There's too much jitter, right? It's still really cool. I like, look at the snaking motion, like it when it rounds this corner. It's pretty cool. These neutrals are, yeah, this is too much. So this is too much jitter. Let's do, we'll cut it in half. I'm incredibly happy with that. So, like, the thing is, yes, they could do that before, technically. But before, they were using a series of waypoints, and they were just going straight line path from one waypoint to the next. Whereas now, we have arbitrary pathfinding that can go around obstacles. What are they getting stuck on here? What the heck are these guys? Oh, they're stuck on the tower. This guy shouldn't be stuck, though. What is this guy stuck on here? I think he's stuck on being stupid. Maybe the jitter? What? Shouldn't be stuck. Well, maybe we will we'll add the towers in. Do we add the towers into the map? Where's the tower positions? Oh, yeah, here, this thing. So let's just take this. And we open a file, don't we? YAML here. Yeah, this is YAML. Let's open this YAML. And then we'll just do tower positions equals what's the is it prefix tier suffix entity data tower name y. So then we'll do boop. This, do we set this to 1 or 0? We'll just try both. And get rid of the cached file. Only... Really? What's wrong with this shit? That's mildly obnoxious. Okay, so now we're just gonna put the tower data into the map. Yeah, so now I can't tell for sure if they get stuck or not. This guy looks like, yeah, they look like they're still getting stuck. Let's remove the jitter just so we can tell for sure. Jitter. Zero times. We'll rebuild this. Now, let's see. I think it's possible that I just have the sign flipped. Does it work? Nope. So we can see here clearly that they get stuck on the towers. Kind of weird that they stop this far away as well. Let's just do, this pathing map is going to be 0 now. Pathing cache numpy. Okay, so now it'll have to pre-compute again. Really? No, that should definitely solve it. They should not be able to get stuck on their own towers anymore. Which is clearly what's happening. Right here. They can't be stuck on each other, right? No, they can't. That's not how the game engine works. This portion here looks good, but something's stuck. So we do this way like this. Let's see what is in the map currently. I want to just make sure we're flipping the sign. So it's 0. So we were correct the first time. It should be 1, which is what I expected. Hold on. So wait. Is it possible that the way that I'm computing pathing, things can still get stuck if they don't move fast enough? If groups of agents don't move for some seconds, penalize. That will not happen with more training. There's no mode. So this is not a training thing. This is... I think what is happening is that when I compute the path maps, right, I'm computing the path, the optimal pathing, assuming that agents move 1 unit per second. But the thing is, if they move less than 1 unit per second, then, like, they could still get stuck on stuff, right? So let's say that the optimal path is, like, you come up to a corner and you want to move diagonally around the corner, right? If you don't move fast enough, you're going to get stuck on the corner. That's a thing that can happen. Right? Yeah, so let me explain this for the chat here. Is this the bad one? Yeah, this is the garbage one. I don't know why this freaking app exists. This one's so dog shit. Is this good? Yeah, this one's fine. So you have a tile here like this, right? And let's say that I'm starting here. This is your obstacle. And your destination tile is here. Okay? So the way that the pathfinding gets computed, it gets computed using L1 distance. No, L infinity distance. Yeah, L infinity. So the way the pathing works is it looks here. It looks, over here. It looks here. And it looks for, a way around this obstacle. So let's say it finds this one. It says, look, if I just take one step to the diagonal, then I get to this tile. But what happens if your agent isn't that fast, right? Your agent, let's say that they move half, or let's say that they get like partially into a tile, right? So it could happen that your agent gets to like right here, and then it does the check, and then it tries to move this way, but it actually can only move this far, so it gets stuck into this tile. Because it can't clip across the corner. So this is not a major problem. This tower patch is going to be better than nothing. We're going to regenerate the map pathing data one more time. And then we're going to add just a little bit of jitter. Say this much jitter. And we're going to hope this is good. We got to tune the jitter amount just a little bit, because I don't want it to be too much. I think that there should only be a little bit of jitter, just enough to break up the symmetries and stuff. We also might want to pre-compute the jitter, which would be funny. I'm literally like looking at that rand function as, oh, the rand function could be too slow. Okay, well this is weird. Now this I don't know what they're getting stuck on. I think we should load this up in human mode and go watch them. Oops, let's get this out of the way so it's not obscuring chat. Pathing map is not associated with a variable. Really? Should be. Whoops. Nope, wait, it's right there. Yep, right there. Okay, render mode goes to human. Huh? Oh, this is just the mouse cursor bug. That's fine. Hold on. Okay, so we have some puffers. They're stuck right here. They're stuck on the tile. So these guys should not be stuck here, right? I think they're stuck on each other, maybe? Did I, like, lose the check to make sure that they don't get stuck on each other? This pathfinding here is pretty good. Boom. No, leave me alone. We will go in for a kill. Yeah. Heroically. So they're stuck on something. Let's see, I might have messed up some logic. So what did I do with this creep pathing logic, right? Ah, it's this thing right here, I believe. This logic. Move to. If. But this looks good right here, because I have this logic. Wait, if. Hold on. If. Oh, this is the jitter function, right? Yeah, this is the jitter function. Interesting. So, let's see this one. So float jitter X and float jitter Y. So this can go in here, right? If grid disk Y. Int dest Y. Float move to Y. Int. Let's make it work and then we'll make it nice. So move to Y. I'm going to get rid of jitter. Okay. And then what we're going to do is we're going to return move to jitter X, jitter Y. It's 2 times speed, 2 times speed times this quantity. And then what we're going to do is move to, hold on, entity, entity.y plus, what the fuck are these suggestions, man? Entity X, jitter X. Okay, so we return move 2, otherwise return plus speed, no jitter maybe? Maybe no jitter. Maybe we determinize for now. Pathing is not easy. Good pathing, good like creep AI, not easy. Possible inconsistent indentation. Cannot assign type float to int. Okay. Let's just go like this. Let's go. How are my puffers? Where are my puffers at? Well, they're not stuck. They pass through this way more cleanly now, right? Render mode is going to be raylib. What do we think about this? Looks way better, right? The pathing. I'd say that's clean. Occasionally one of them can glitch. We're going to increase the jitter. We can actually, this is the nice thing, is I think we just do, we don't do 2 times speed. We just straight up jitter them 1 tile. This is a 1 tile jitter. That is a lot more aggressive, but the thing is we only do it when they're stuck. So if we only jitter them when they're stuck, that'll be better. It might be a bit much, we'll see. I gotta check what the default move speeds are. I think it's like 0.5. I mean, that's like perfect though. Right? And like look at the fight, like the frontiers on the fights. I just want to point this out. Like look how clean these frontiers are. Like you get like these actual like organic looking battles because they like, or they just like jitter until they find a spot that they can fight like the nearest one. And like you get this like snake like pathing around all the waypoints. These are the actual Dota waypoints as well. That's freaking solid. Now, the neutral creeps, we're probably going to let them just chill out because they're like spazzing. They should kind of just be chilling in place for the most part. I'm very happy with that. Why is this gray one spazzing out? Oh, they're allowed to spaz out randomly. It's just gotten lucky. That's fine. Yeah, so these ones, like, they are way less locked in. Oh my gosh, do you see this tower? This red one is pulling this tower around. Do you see this? This red one just pulled the tower all the way. They friggin' pulled the tower. They pulled the tower through the wall as well. They deleted the wall with the tower. Okay, guys, I told you I would leave this in as an Easter egg, but, like, are we sure? That's freaking crazy. That they're just, like, this is them acting randomly. Imagine that they actually play this, and they just learn to pull all of their towers to right around the Nexus, and just sit there. Like, what? What are you gonna do? You're getting hit by freaking 9 towers. Just becomes a game about pulling the enemy's towers. Okay, we gotta kill this before it kills us with the memory. Oh, that's so funny. How's the Twitter? Have we gotten a million billion likes? Oh, he's still live? Had to take a break, I see. That's no good, Will. Not bad. Happy to say we broke 4K on the account. So the growth has just been awesome. And if I recall, Pufferlib is oh shoot, we got 660. 661. This is awesome. Right here. This is just great. I really hope we can keep this up. And this pace of growth is just great for the project. Yeah, I hope so. Like I think that the one that will potentially do very well is the one that I already posted. You're not going to be able to tell the pathing difference just looking at the MOBA without looking very closely. It's the key thing is the new pathing is just going to make everything less glitchy and bad. So before, let's say that you lured a creep. If you lured a creep somewhere random, it basically would just be stuck. Now it will actually correctly path back to lane like in the real game, because it has perfect pathing from anywhere on the map. With the one exception being that if it gets... there's weird discretization stuff where it can get stuck on an obstacle, but then it'll jitter out and it'll continue its path. So it's pretty efficient. I really like this demo. Wasn't that hard either. It's funny. Okay. Let's try some stuff out. So we should be able to simplify and clean up a lot of the NPC logic with this, and possibly even add like some basic scripted player control to this. And definitely we should be able to improve the human player control with this as well. So it's 5 p.m. I think we can be a little more ambitious than just that, right? Let's start with this. So first of all, this creep path thing no longer needs to be a function. Because if we go to here, waypoint is creep.waypoint. Okay. What we do, move towards, is what we did. Okay, move towards. And do we have float dest y? We do. Agent speed, be fine. And then this is also move towards this. So let's try this to start, right? We forgot that we need this in the neutral NPCs as well. Move towards. So right here, if found target, move towards. Elif, L2. So we're basically always going to do a distance calc, right? So we can just float dist. No, we can't because it's a different L2. L2 is less than 2. Then you path towards your spawn if you're like not close enough to it, right? And then we delete creep path, which is a nice big block of code to be able to delete. I'm happy with that. Which puts us now at 1147 lines. Let's see. I think we just confused some variables. It's that time of day again. Very happy with the progress I've been putting in. I'm not actually all that happy with my hours, though. I would like to be putting in more hours. I don't know, I've been getting tired fast. What the heck? This shouldn't be creep path. This should be move towards. Right? Agent speed. Yeah, this should be this. Into dest y. Move towards. This is target.y. Nice. Perfect. These creeps are stationary. They should be stationary. Now the question is, if we do render mode human and we screw with a couple of them, if they're still stationary. Here we go. Here's our MOBA. I'm going to boost on over, and we're going to say hi to the neutral creeps. The neutral creeps are kind of hidden in this terrain. We can fix that. Boop. Ah, no, they're attacking. And if they stop attacking, do they path back to their target? Okay, so they get stuck. Let me just double check that they don't have two. Okay, they get stuck at the moment. Let's figure out why that is. Scan AoE. Exclude friendly. Exclude hostile. Do you intend to let neutral creeps be pulled into lane creeps? Oh shit, I forgot. Is that a thing in Dota? Do the lane creeps fight the neutrals in Dota? Pulling, yeah. It's been so long since I've played, man. I haven't played since like OpenAI 5 days. Done on Radiant Bottom or yeah, okay. I used to play P4 Lena, which tells you that I have no idea what the hell I'm doing. Um Let me think. Yeah, I remember you would pull the camps, you could stack the camps. There's a lot of shit you could do, right? It's interesting. I'd be open to it. Not the first thing I'm going to implement, but neutrals near mid look very close to the lane. Could work out on all lanes. They shouldn't be any closer than they would be normally. I guess the map is slightly downscaled, so the character model should maybe be smaller. But this is the exact Dota map. Like, so here's the Dota map, right? This is exactly where all the obstacles are on the real Dota map, just downscaled. Everything should be 1-to-1 the same with that. Let me figure out what the heck is happening here first, because this is higher priority. I think what I was going to do is I was kind of just going to code, whatever the heck I can do with the MOBA to make it interesting, and then get some kind of cool RL models on it. That was going to be the highest priority thing. And then if people like this project, if this project gets enough attention, then what I will do is I'll open it up to some Dota players and say like, hey, what are some of like the most important things about Dota that I'm missing here that, maybe I could easily add a few modifications, right? Awesome project, by the way. I was watching videos on YouTube. First time I caught the stream. What map version of Dota are you using? I think it's really old. I think it's like 7.3 or something. I can update it very easily is the thing. I just need the data files in like a reasonable format. So I found some repo online that had already like scraped all the tower positions and scraped the neutral positions and like the map data and stuff. So I'm using that. I only found one from like 7.3 or something like that. Um, I have no idea how much it's changed over the years. No idea. Like I'm sure it's changed in ways that Dota players find like yeah, they make huge differences on the gameplay. But like visually, if you were to look at the map then and look at the map now, are you immediately going to go, "Oh, that's totally different," or is it like at a high level the same thing? Like I know League redid they redid the way that the jungle worked. I don't know last year, and it was like a huge thing for the way that the gameplay is. But for anybody who doesn't play League, like you look at the map before, you look at the map after, and it's like the same map. Found target. Found target equals scan AoE. If found target, nearest scanned, basic. Otherwise, move towards. Elif, spawn Y, spawn X, less than 2, move towards. Neutral spawn Y, neutral spawn X. Why is this not valid? Hmm. Do they spawn inside of do they like spawn inside of terrain or something? Hold on. Maybe this is just like a bad spawn. I don't know. I'm not really human mode. But yeah, the goal is not to spend forever on this project, right? Like, I want to do a whole bunch of cool stuff on stream. I don't want to get stuck on this forever. Come on, Puffer. Yeah, you know you want to follow me. Whoop. Haha, what are you going to do? You're going to stay there and be stuck. You get blink striked on. I don't know why this blink strike drains my mana like that without teleporting me. We got stuff to fix, but so it just doesn't frickin' follow me. L2 distance of neutral.y, neutral.x. If found target, if the L2 distance, you're going to basic attack, otherwise you're going to move towards me. L if, what the hell? Why does this not do it? Neutral.spawn y, neutral.spawn x. Move towards. And moving towards. I don't know if you've seen them as well. I guess I really need to upload the Snake dev streams to X, because that was the first week. I built like this 4096 player Snake game in a week that runs at 14 million steps per second, single core. That was like an easier to follow stream as well. Because that environment is like way simpler than this. Way simpler. Okay, puffers. Pull the puffers. Come on, puffer. You know you want to follow me. Okay, so now it says moving towards a whole bunch, right? And now he's no longer moving towards. Oh no, he is still moving towards. What the heck? Hmm. Do you have a good resource to learn ML? Wanted to make a game similar to Total War and make an AI for that. Oof. You're jumping in at the deep end. So I've worked in natural language processing, vision, and reinforcement learning. Reinforcement learning is by far the hardest because in addition to the things that you need to learn with ML, you need a substantial bit of engineering to deal with the simulation stack, right? Not to mention we have a bunch of very cursed things as well, though I'm working on that. ML in general, CS231N lectures online, either Andre or Justin's, probably the best place to start. Reinforcement learning from there, the fundamentals aren't all that complicated if you get ML. A little bit of math, not too much. The main thing is just ridiculous quantities of engineering. You know, I spent 4 hours today pre-computing pathing. I don't know if you were here for this. I spent 4 hours today pre-computing pathing. This is 268 megabytes of pathing data. And as a result, the simulator can now do pathing while running like 1,000 times faster than it would otherwise. Like this is the level of stuff that it takes to get really high performance sims that are going to be usable with reinforcement learning. I mean, that said, it is just getting easier and easier, and the approach that I've been taking with Snake and with this project and with all the other sims I've been developing is one that I would say is fairly accessible. It's something that you can pick up for sure. It will take some work. It will definitely take some work. Fundamentals, though, start with 231N, go from there. RL, I forgot that it's kind of dated, but for RL, there's OpenAI's spinning up documents. It's way more math than you need, and the code isn't great. Still probably one of the better resources. You can also just read through CleanRL. CleanRL is awesome. Found target. Move towards. Right? Does this say moving towards still? I think I might just not have been paying attention. No, it says moving towards already. Right, because... Oh, stupid. Stupid. There we go. Man, I gotta not be messing up my code bases towards the end of the day, because I just, like, miss stuff like that. Alright, puffers, what do you got? You got game? Hiya. You got nothing. That's right, you go back to the hole. Here, we're gonna lure a puffer. Hey, puffer, what are you doing? What are you doing? You're doing nothing. Go back. Get AoE'd. Cool. Isn't nice? Very nice. Why do the puffers go underneath the map? It'd be better if they went on top of the map if they were going to clip like this, right? Pre-computed pathing is very cool. Does it rule out any dynamic map changes though, like collision with other... Nope, you can still collide with other entities. You just can't account for them in pathfinding. which you wouldn't be doing anyways. P-dubs, the difference in computational efficiency, though, with doing it this way versus like trying to do A star in the loop, it's like a difference of like factor 10,000 or something. So yeah, it's massive. Stuff like this is what's going to let this run 1,000,000 steps per second. P-dubs is the original author of the viral Pokemon Red reinforcement learning project. Been helping out with that with Puffer, mostly just sponsoring compute these days, but awesome project. Go check it out if you haven't already. Okay, so this now works. What was wrong with my renderer again? Oh, right, I forgot I still was using the old renderer for the grid. That's obnoxious. We're probably going to swap this out anyways, right? Let's hit... This'll do it, right? This fixes it. Whoops. Hey, B-dubs. Welcome. Tile is 0 or 2, continue. And then I forgot to just define this here, right? And we're just gonna hack this because I'm gonna replace this client anyway. I wrote a better client. So this will just make it cleaner for the time being. Because now when you do weird stuff, yeah, you'll go on top or you'll go through the map when you do. So like if I boost towards this, you can boost through it. Just depends on your speed. And then you can actually see the targets. Oh no. What's the data format for pre-computed path? How are they looked up? It is a 268 megabyte 4D table. You index it with destination Y, comma, destination X, because assumedly that's the thing that's changing the least often. So for cache coherency, those go first. And then your current Y, your current X. So simple 4D table lookup. Takes 3 seconds to pre-compute those 268 megabytes of data, by the way. The Cython implementation for pre-computation is 3 seconds. That's about 3,000 times slower than the Python implementation. 3,000 times faster than the Python implementation. So the Python implementation would literally take hours to run. So I Cythonized it both because it would be cool. It would, save me time ultimately not having to wait for the thing. And also I don't have to distribute a 260 whatever megabyte file. Right, I just cache it the first time you make the environment. So you only get 3 second startup once. And after that, you have much faster startup. Okay, so this is good now. We made the renderer a little prettier. Technically, we could get a nice background for this. If we wanted to, we could paint like a cool background for this. I don't want to use the Dota map. I think that like using Dota data for a science project, that's one thing. Using their artwork, that's kind of sketch. So we're not going to do that unless they tell me I can. $530 wasn't that bad. Let me think what else we can do for tonight. Let me think of something cool. How many paths is that in total? Well, it's from every tile on a 128 by 128 map to every other path, right, on the map. So behind each index is a full path? No, behind each index is the movement that you should take, right? So if you want to get to dest y, comma dest x, and you're currently at start y, comma start x, what move do you take? And then you do the next lookup with your new start position, and you get your next move. So that's 128 to the fourth is 268 million. We're storing it each action is 1 byte. So that gives you 268 MB. Also, had you seen precomputed paths used in other projects, or is this just what made sense to you? This is just what made sense to me. I haven't seen people do this. I mean, maybe there are probably some projects that do it, but I'd assume it's pretty rare. I mean, like, if this were, when you implement this efficiently, like, you could do this probably 10,000 plus times per second if you wanted to, and you don't ever have to, like, update the paths that often. So you could have a game with 1,000 players doing this in real time without pre-computation, no problem. But the thing is that this game is going to run at 20,000 times real time per core. 128 squared? No, not really. It depends what you mean by how many paths are there. Like, the number of paths is technically from any node to any other node on the graph, right? So the number of nodes is equal to 128 squared, and then the number of paths is 128 squared. So there are 128 to the fourth different possible paths. And they're stored in 128 to the fourth bytes because the paths all overlap. So you can, you don't have to store the individual paths that way. Otherwise, it would be ridiculous. You wouldn't be able to store it if you stored the individual paths like that without overlap. And it wouldn't even be any faster. I think the chat is pretty delayed. Let me see. Edit settings. Do we have stream settings for YouTube? Is there like a stream? No, hold on. Let me do this off screen. Settings. Playback and performance. Is there streaming? Are there like streaming latency things on YouTube? I seem to remember there being streaming latency settings. I'll mess with this later because I don't think I can do it while keeping the stream up. I think it's like 10 or 15 seconds. I didn't notice the last one for a bit. But yeah, when you see your message pop up on my screen, that's when I can see it. It shouldn't be 40 seconds. That's ridiculous. If it is, that's YouTube being jank. But basically, as soon as you see your message pop up on the actual stream message there, I can see it. If I were to open the YouTube chat window, I'd be able to see them instantly. I don't have that open, though. I just have the plugin. It's only delayed about 5 seconds? Okay. Yeah, I don't know then. Okay, next stuff with the MOBA. There was so much stuff I wanted to do with this project, but I want to figure out like what are the key things we need, because I'd like to have models training on this relatively soon. Message is taking like a minute to show up in the stream after sent. That's weird then, I don't know. It can be endpoint specific. I don't know if you're on mobile or whatever. But it's weird. I haven't changed anything in my settings as far as I'm aware. Oh, it's my fault. I was watching the video a minute behind. Lol. That's funny. Okay. Stuff to do on this project now. There's some game balance stuff that we have to do. There is a little bit of debugging stuff that we have to do with specific skills. It would be cool to get, like, some sort of baseline type thing. Like, can we just have the... What if we just, like, make the agents run at each other down mid? Or, like, run at each other down a specific aisle? So, are there multiple heroes? Yes. We have 5 different heroes. We don't have, like, 20 heroes, but we have 5. I'll show you them. We've got a support character that has a hook pull, an AoE heal, and a single target stun, I believe. We've got an assassin character, that's the one that I've been playing, that has an AoE that can only target creeps. They have a blink strike, so they can teleport and hit. And then they have a channeled movement buff, 2x move speed. There is the mid character that's supposed to be bursty, so they've got a single target nuke. They've got a pretty strong AoE, and they also have an AoE stun. Basically modeled this off of Lena. And then we've got, there's a tank that has an AoE damage over time, a strong self-heal, as well as an engage AoE. And then there is a carry. The carry, or the bottom whatever, has a retreat slow, a spell that they can use on an enemy to push themselves back and slow that enemy down. This was modeled off of, like, Caitlyn's net, if you know that. There is a slowing damage, so you can use it to poke and also slow the target. You can use it to, like, cut them off from retreating, lots of things. And then they also have an AoE to help them farming minions. Can other heroes see what heroes are, with the purpose to know their strength or weakness? That will be implemented. I haven't implemented it yet. I just need to have different graphics, basically. I need to, like, make different character graphics or something. I don't know. Maybe I should just, like, export a 2D of the puffer swimming or something. That'd be fun for movement. I think what we're gonna do for today, because it would be fun, let's try to just, like, hack the creep AI to make it work with the heroes, right? So we can have the heroes run at each other down, 3 different lanes or whatever, and then we can run the game really, really fast, and we can see if, like, anybody actually takes all the towers, right? And we can get some cool graphs or some cool stats on, like, levels and stuff like that. I think that would be a cool thing to do. Yeah, because then the thing is, once we know that, then we can, like, start tuning stuff around that, and then we can start doing, like, a little bit of RL stuff around this. Because I want to start working on the neural net side of this no later than Wednesday, so we can start getting experiments running. Because it's going to take a little bit of work. How did you learn coding? I'm in uni first year and it's so hard to code. Any advice? Takes a long time to get good. I started programming, I guess we'll say seriously, at like age 16 or 15, but really more like 13. So 13, 14 years by now. I've been doing research for most of that amount of time. I've been doing like software heavy side stuff in research for most of that time. I've always had like tons of side projects and other things that I've been working on. And it really, really pisses me off when I write bad code, which is the biggest thing. I make a few exceptions for this stream so I can get stuff done fast, but then I always go back and refactor stuff. These skills aren't bad. Just create a class, be able to add, edit, remove a class. Yeah. Little games are fun. You can try to implement like a basic snake game or whatever. That's like you can do that in 200 lines of code. Let me think what we're going to do here. So I want to hack this. Creep AI. What happens if I just call creep AI on the heroes? Can I just do that? I think I can, right? Just call creep AI on the heroes and have them not use their skills yet. I think I literally can do that. Hold on. Let me apply the lanes and stuff to things. Ugh, I have to go copy. I just need to see this for a moment. Okay, so all I have to do is self.get entity player of player 0 yeah dot lane. This is lane 2, I think. Creep.lane. Where do we set the lanes here? Yeah, that's where. So lane 2 is the bottom lane, so we're going to set support and both supports go to the bottom lane. Oh no, wait, that's wrong. This is 5. Get entity 1 lane is the assassin is. Oh yeah, this is supposed to be a roaming character. I actually don't know where to send this roaming character, so I'm just going to send it to the top lane for now. Because I didn't account for that. Like, it's going to have to learn how to do other stuff. Get entity 2. This is the mid character. This is going to go mid. 3 is going to go top. And then 4 is going to be bottom, which is 2. Okay. So, and then we're going to do self get entity 5 is going to be sent to lane, the bottom lane, which is 5. Get entity 6 is going to be sent to the top lane, which is 3. And D7 is going to be sent to the mid lane, which is 4. Get entity 8 is going to be sent to the bottom lane as well, which is 5. Get entity 9 is going to be sent to the top lane, which is 3. And self.getEntity10 is going to be sent to the bottom lane, which is 5. Okay. Remove all this. I was just using it as a reference. We need to move this down one, like this. Hardcode lanes for now. And then what we're going to do is we're going to do the creep AI on the players. So player logic right here is going to be, okay, so they have this for their skills, I guess. Let's just comment these 3 lines. Creep. Yeah. I wonder what this does. I wonder if this works. Render mode. Okay, lib. Oh ho. Well, would you look at that? Why is this one stuck? Okay, very weird that this one is stuck. But overall, look at that. Boom. Why is this one stuck here? This is so weird. I don't know. Nobody's taken a tower yet. I would also like to know the levels of these various things. Did they take a tower in mid? I didn't see. And do this so that it doesn't clog memory. Yeah, they took a tower. Okay. That's a start. Let's do a little logging, maybe. Was it entities? Entities dot. We gotta put this here so we can. We're gonna get the levels. I want to see them level up. Okay. Okay. NumPy float 64 object is not callable. Garbage suggestions, I guess. We'll just do the means. I can't see this because it's going too fast. So what are we gonna do? What if we just do %32? Will this do it? How is this so fast? Oh. Okay, let's try this. Ha 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 ha. Is that fast enough? They're leveling. Level 16. And then we get to the really rare bug that I have to fix. Cool though, right? I don't think that we've actually given them stats yet. So maybe that's what we'll do. Maybe we'll do stat scaling for a bit. Because what I would like to have happen is I'd like to at least have the ability for like, I'd like to be able to run this game super fast like that and see that you know, eventually the players just start murking the creep waves or whatever. Though the creep waves scale pretty hard in Dota too, don't they? The creeps get stronger. But still, by the end, you're like one-shotting the creep waves, right? Yeah. Okay. I will be right back. I'm going to use the restroom. Then we're going to do another hour on this. And we are going to, we're going to get something that actually looks like a winnable game of Dota. And I think we'll probably add in the Nexus objectives or whatever they are. Fountain. No, not Fountain. Nexus. And then we'll set the win con of the game. That'll be cool. Be right back. Okay. Let's make this thing freaking awesome. What is the issue right here? Oh, there's no issue. This is literally just the GIF saving. Oh, did we actually go through all these frames? We simulated 10,000 frames. That's funny. So there's no bug. We just simulated 10,000 frames. Faster than I thought we could. Do we have any form of scaling in right now? Doesn't look like we have any form of scaling in. Cool. What do we have their damage set to? Health, mana. We have their basic attack damage set to. Basic attack. Basic. Oh wait, I saw it. Player dot. Here it is. Reset player dot damage. You have it set to 25. Which is very low, isn't it? I think I used Lena as the model for this. It's probably way too low. Give me another hero. It's like a reasonable thing to hero base damage. What's like a middle tier damage? Base attack damage. Oh, it's actually not that far off. The really high ones are like 30s. Agility heroes. Okay, so like some of them are really slow. Really low. Okay, I think 30 is a good one to start off with. And what's the scaling? What's like good scaling or like random scaling? Attack damage scaling, Dota 2. Main damage sources. Selected attribute. Does anybody just want to tell me how much scaling you get roughly? Bonus attack, no. What is this? Strength. What is it? Main attack damage per point. You get 1 damage per point. Right? Detailed table. Main attack damage at level 1. Wait, what? Base attack damage and main attack damage. Oh, because it's with the scaling. Right. Okay. So I was underestimating, drastically underestimating. It should be more like 50. 50 base attack damage, which is about what a creep does, right? Isn't that what a creep hits? Maybe a little more. Yeah, so you do about that amount of damage. So let's up this to 50. Because we don't have strength scaling or anything. And then we can do... How much do they get? So we can actually max main attack damage. We can get it right here, right? That the average is like... Well, it depends on how much they scale. 150. I'm seeing a lot of 150s, 140s, 160s, 120s. 140s, 120s. Let's say 100 and... Whew, what the heck? Some of these are like crazy. Okay, let's say 150 damage. So it's 100 divided by 30. So let's say 3, it's 90. Is damage a float or an int? It's a float, so we'll do 3.3. Self.level, player.xp. Here, .damage equals 50 plus 3 times player.level. Simplest scaling we can do. And then the max health as well goes up, right? And max mana. We're going to have to organize all this data. I just want to get something to start with. Player.max health. 500 and 100. Okay. Plus. And now we need to have player health, right? And no health scaling. Where's the frickin' scaling? Talent grants them a flat health bonus. What is the health scaling? Base health, 20 HP, 22 times base strength, plus level minus 1 times, 22 times strength. So, (22 times base strength). So, I don't know what the hell that's going to equate to. There's not a table of level 30 health. Strength, agility. Oh, here it is. Damage max. VSD. What is this? Do we have health on here anywhere? RG. Int T MS T30. Move speed. What the hell? Where's health? Is health not in here? Attack speed. Well, at least we see the HP and MP per second, which is... Okay, that's nice to know. I'm just going to guess because I don't know. They don't have 3,000 health. I'm going to say it's 50 health a level. So 2,000 at 30. I don't know. Player.level. And then we're going to do 100 plus... Well, I'm going to actually leave the mana as is right now because I don't have that scaling set up. But I am going to actually I'm going to add a very slow heal. I'm going to add a player dot if player health. Okay, so now if I rebuild this, I think we should see him murking some enemies. With some basic scaling. Level 4. One tower's been taken. This invalid XP. Level 17. Invalid XP. I guess somebody broke level 30. Rebuild. Definitely the heroes they're still getting stuck in stuff at places, so we're gonna have some glitches to fix. But let's see if we can get these things taking some towers. And if this doesn't work, I'll make it asymmetric. Because Dota has like the hard lane and the safe lane thing. Okay, so they both took each other's mid towers. One top T1 has fallen. I think that they're just spamming their skills, and they're not actually hitting with them. Nothing is happening because they're already at level 26. So let's see about that. If you use Q, Yeah, these need to all be beants to tell you if they've used them. We're going to replace this with basic attack for now. And the reason is just so that we can tell, I think that they're spamming skills without knowing what they're doing, using them for. And as a result, they're not like just using their basic attack to kill NPCs, which should be incredibly effective once they're level 20 something. Let's just rebuild this and try this again. Oh, it's Monday. Actually, I can stream a little later today then maybe. At least while I'm getting stuff done here. Okay, so... Okay, there's a tower fallen. Top T1 is fallen. So Dyer's lost 2 tier 1s, mid and top. I could probably make a jungle AI without too much difficulty, right? Maybe. Is that... Yeah, mid just lost tier 2. We're at level... Radiant is at level 30. Dyer's only at level 19, which is odd. But then if Radiant is at level 30, they should be sweeping. Though I guess they're not using abilities. And there's no scaling for item builds built in. They're pushed back very, very far, though. But they are holding. I think it's because a couple players keep getting stuck. Or maybe just the tier 3s are very, very strong. The minions don't even have scaling on them at the moment. So they should just be getting wrecked. Though I guess, again, they're not using spells. And there are no items on. Okay, so the thing that we know will definitely cause this... It's a mirror match, so it's hard to say how long it should take for somebody to, like, win. We're going to make this more Dota style. This, like, 1-1-2 jungle is it's a league thing. Let's make this more Dota with the lane assignments. This should help. We're gonna do... Okay, we're gonna do the entity assignments again. So it's what is it? 1-5 support 0-6, and we actually need to swap these. 1. So 0-1-6 2 is these suggestions are so stupid. This is burst, not tank. Then this one is tank, this one is carry. Okay, so we're going to assign support. Screw it. Support, assassin, and carry are all just going to go to the safe lane. So 0, this is going to be lane 2. 1 lane is also going to be 2. And then, what is it? Entity 4 is going to be lane 2 as well. So this is the safe lane. Then we do self.get entity. The mid is going to go to 1. And then get entity, this will go to 0, okay? So this is 3, 1, and 1. Get entity 5 is going to be lane. This is their support, so their support goes to their safe lane, which is 3. So 5, 6, and then what is it? Their carry also goes there, so 9. 9 goes to 3. And then their burst goes to lane 4. And then their 8, which is their tank, goes to the off lane. So this should be more the Dota meta, which is actually way better for this, the lane assignments, because it makes it asymmetric, so it makes it easier to see a result. Because the expectation there is that they should both push into the end of the game, right? Because it's 3v1. Okay, let's see how fast this happens. So, not particularly fast. No, there's a tower that's been taken. It's the wrong side, though. That's supposed to be the, Are the lane assignments right? I want to run this slower. I want to run this way slower. Now we're going to run this where we can actually see what's going on. Okay, so they have 3 assigned here. Then 1 and 1. Yeah, okay. So this is good. This is good, right? And maybe they don't have the attack AI on. I think they don't have the attack AI on. That's got to be it. Creep AI. Move towards basic attack. So they don't actually need any of this shit at all. Right? Yeah, because that's going to set the cooldown to be jank. So we just are going to comment all this skill stuff. And they're going to just use the creep AI in their assigned lane. And then we're going to see what that does for us. It should be the same thing, right? It's just that these guys scale, so 3 of these pushing down 1 lane should equal you win the game. We're going to run it slow so I can catch bugs, maybe. Hold on. Okay, so here it is. Okay, so they did get a wave advantage. Yep, so actually on the first push, they got all the way to the tower. And then they all went down mid. Okay, so it's the lane assignments that appear to be breaking, right? Yeah, the lane assignments are 100% breaking. So, respawn player. Move to. Where is this breaking? The lane assignments get broken. Move to. Creep AI. Oh, I have to reset the waypoints, right? When you spawn the creep, you reset their waypoint to 0, right? We do Let's see if that fixes it. Because if they were all going down mid, then it's not going to work. Okay. So here we go. Here's our first push. They get pretty far, right? They get all the way to the tower. And here they come back. But wait, is this working? Yes, it is. I should probably swap the colors with the creeps. Because the gray ones are the heroes in this case. So they've pushed to the tower. The thing is, they are trickling. They're only level 4 as well, which I base the scaling off of Dota, so this would be very early to take a tower anyways. Radiant is now level 3.4. Dire's level 5.4 on average. I don't know why there's such a big difference, but hey, who knows? Maybe there's some weird asymmetry. Okay, they're pushing to the tower. They're having a hard time, it looks like, getting past the tower, which is reasonable because towers are strong. They do a lot of damage. They are pushing all the way to the towers, though. And then mid is... not much. They pulled a neutral creep and it was just hitting them. That was funny. So this is crashing for some reason. Hold on. Hopefully the computer doesn't go down. This is ridiculous. Literally not letting me kill it. This should not be OOMing though. That's weird. I don't think it was appending the frames to this. Yeah, this is locked up. There we go. This is... Where's the stupid Python kill script? I don't know why that's happening. I should not be saving the frames. There you go. It's the only one that works. I don't know why. That's a little bit of a bummer. What's happening? Yeah, I'm not saving the frames. Right? That should not be ramping memory usage. Something's wrong. Can't be any leaks. We don't allocate any memory dynamically, so something's just being cached weird. Let's watch what happens here. So we're not going to play it. We're just going to watch what happens when they play it for us. So here we have our bottom safe lane. We fight. Right, I'm not allowed to have the mouse outside of the screen. I haven't fixed that bug yet. That's just a render bug. Okay. So we should see them attacking, right? Yep, lots of damage. I saw him getting chunked. I don't know what killed us at the end there. That was a lot of burst damage to be taking. Looks like they get stuck on the tower waypoint for just a moment. And then we are level 2 now, so we have 600 health. Do a little bit more damage. Okay, we died at a relatively reasonable rate inside of a full pack of minions, right? Not getting that much XP, but then again, I have it set right now, so you only get XP on last hits. Okay. I saw it did a lot of damage and tanked a bunch of stuff. I'm not seeing anything immediately wrong. It looks like I'm going to have to fix that leak, but in the meantime, I'm guessing it's based on frames and not simulation steps. So I'm just going to run it super fast. And I'm going to run it in the Raylib mode. Okay. So here we go. We should be able to watch towers being taken. It does look like occasionally the AI gets bugged. Because I can see on the left there's a player that's just frozen. Radiant now has level 24 players. They should absolutely be taking this bottom tower. Dire's caught up. Let me get H-top just to make sure we're not killing our memory. No, we're fine. Whatever it was that caused that before doesn't look like it was just, we are actually leaking memory. Very slowly, though. We'll kill it way before then, no worries. What the heck is going on? Why aren't they taking towers? Oh, there we go. Radiant just took the their first tower in safe lane. About time. Oh, and Dyer's taken one as well. I just didn't notice it. So yeah, this is exactly how it's supposed to work. It's just being slow. I would expect this to have happened by now, so I guess the scaling is just off.